Hello guys and welcome to a new video series. I'm Dean.
I'm Felix.
And you're watching a build with Billet Labs. So we've been commissioned by a customer to put together a small form factor PC. They have selected these components you see in front of us, and it's up to us to figure out how to fit all of these and the cooling into a 13 litre case.
So let's take a closer look at the components and see what we're working with. So here are the components that the customer has chosen. Obviously we've got the monoblock, we've got a i9 14th gen, we've got a 4090, basically everything to make it as hot as possible. But the case, this is a Johnsbo N1, it's a NAS case, but looking at the overall dimensions, it looks to be the perfect size. We haven't opened it, we haven't looked at it, we don't know if everything will fit, but we think it will. So we're going to open it now and have a look.
Okay, the Johnsbo N1. Let's see what we are working with here. Wow, that is a pretty case.
I mean, we're going to have to chop a big hole in the side, I think.
No, it's too pretty to chop a hole in. Let's take it apart and have a closer look.
So, is
there
that,
appears to be a thumb screw on the back.
Shall I do it?
Give it a go.
Oh, we got a cable in there. Okay. So we're going to have to chop out most of this.
So being a NAS case, it's got this board for multiple hard drives, which we will not be needing. So straight away we're going to be getting rid of this cage.
Also this fan, I think to fit everything in, we've worked out from our other build that we're doing as well at the moment, that we need, what is it, about 330 millimeters.
Yeah.
This case is 340, I believe. Might be 350, but this fan is definitely taking up much too much space at the end. So we're going to have to lose that.
Okay, I think the next step is to remove the hard drive cage and actually fit a motherboard with the monoblock attached, just to see how it sits.
Yeah, agreed.
As it stands, this cage is in the way.
And we've looked at the specifications for this case and the CPU cooler height it can handle, and our monoblock is within that dimension. So we should be able to fit the motherboard on the original standoffs with the monoblock on top of it.
Well, let's explain first, why did we go for this version of the case? Because they have a similar version which is a more conventional sandwich layout, right?
They do, you're right. I think it's I forget what the model number is. The customer liked the look of this, which is probably the main reason that we started with this style of case. And
we didn't expect to keep much of the innards anyway.
Yeah.
Because the monoblock is quite unconventional in how you assemble it to a case.
Yeah, but yeah, to answer your question, we chose this case rather than the other slightly different version of it because it's much easier to work with a solid piece of aluminium rather than a piece of aluminium with mesh and perspex on the side like the other version has.
Okay, so that's the case. We're going to have to remove a lot of the innards, the hard drive cage, this board, the fan, leaving us really with just the motherboard mount. And Felix thinks, and to be honest, I think he's right, this side panel is not going to give us enough cooling. I like the idea of keeping a nice pattern on the side panel rather than having a big hole.
But we can do something pretty, we can do something nice with that, definitely.
Yeah, because it's a shame to ruin such a nice bit of metal. But the most important thing is getting all of our components inside here. And that includes a radiator.
Yeah. Something good that I've noticed as well is this whole internal structure slides onto this. It's like a dovetail at the bottom here. So we don't need to worry about mounting stuff to the outside of this part of the case. We just need to make sure it's one solid assembled block in there. And as long as it fits within the outline of the shape of the case, the whole thing will slide in, so that does make it easier.
It's a nice design, and the fact only one thumb screw got into the case, I really like that.
Yeah, that's going to be nice for taking it apart, servicing it and stuff like that.
Okay, let's take it apart.
Let's do it. Cool. So we've stripped out most of the case. We've taken all these bits off, this daughter board, the fan, and we're left with this. We don't have much of it left. Because we've taken away a lot of the bracing, this motherboard panel is quite wobbly, so obviously that's not going to work as is. So this is our test ITX board. This isn't the final board that the customer wants. We don't want to be using their board and get it scratched up and stuff while mounting it and unmounting it multiple times.
Okay, so the next step is to get the motherboard into the frame. I was going to call it a case then, but there's not much left of the case. So we're going to get this mounted, get the monoblock mounted onto the motherboard and see if it fits. Because if it does, if the motherboard and the monoblock fit into this half of the case, then we have all of this side of the case to play with for cooling. I'd imagine this would just be radiator and fans. So, let's get this in. Okay, so there we have it. The motherboard and monoblock are in the case. It fits. If anything, we've got too much space.
Yeah, I was going to say, I think it fits too well. Like there's wasted space here now. Should we put it in the outer case and see what the gap is like down that edge?
Let's do that.
Yeah, that's such a big gap, isn't it? Like 10 or 12 millimeters of wasted space.
So the original mounting position for the power supply is here, obviously, but we cannot go with this. We have to have the power supply and pump over on this side of the block. It's finding the best way round. It's going to be something like this. Pump here, power supply here, radiator over this side.
Yeah, so the case would be kind of split in half, like everything cooling related this side, everything else this side.
And we've still got to get tubing in there as well. But there's plenty of space. 13 litres is a nice amount of space to work with. There's plenty of space to get tubes and fittings.
Yep.
Now, we cannot afford to go any smaller than what we have here. This is a 280 by 45, is it?
55, I think.
55mm radiator, and it works. With fans at full speed, it keeps the CPU and a 4090 cool.
It does. We haven't tried it with a 14900K, which we're using in this build, but we've had it with a 12900KS, which is similar in terms of heat.
Right.
And yeah, we've had them both running, and neither of them thermal throttled. I think we were at, 50 degrees on the GPU and low 60s on the CPU. What I'm worried about, though, is whether the wasted space we have here, because there's a gap of about 10 or 12 millimeters between here and this inside face, whether that is wasting space that we could use for a thicker radiator or a thicker fan on this side.
Because at the minute, I don't even think you might just about get 15mm fans onto that radiator. You will.
Yeah.
But you're not going to get a 25mm fan.
Another option is to, if you've been watching our other build that we've got going on, we are making our own case, and we could use that layout to switch this around. So we could have the monoblock mounted to a hard panel here, the motherboard, sorry, mounted to a panel here, then have the monoblock basically take this half of the system, put it here, and then stack the radiator and the fan on top. And that might be a better layout. What are you thinking, Dean?
The problem with having the radiator on this side of the motherboard and monoblock is you've restricted access to the motherboard even more. Having the fan on this side isolates it from the rest of the components. If you want to get in there and switch your SSD or RAM, it's easier having the motherboard on this side away from the radiator. anyone who's worked on a small form factor PC could tell you, sometimes it's a bugger working on these things. And that's what I like about this case. It's actually really easy to get to the innards.
Yeah, you can just see everything
So
with one screw undone.
Exactly. So I want to keep the feature of this case.
Yeah.
It's nice to work in. It's got a good layout. It's got bad cooling. So that is definitely something we're going to have to change.
Yeah.
And like you said, we've got wasted space down this side. And if we want to squeeze all of the performance out of the cooling system, we have to bring this over. It's only going to be by 15 mil or so, but that's the difference from having 15 mil fans to 25 mil fans.
15 mil is a lot.
If you come out and have a look at the rear I/O,
Yeah.
what we're going to do is move the rear I/O over to the right slightly. We're obviously going to lose this cutout for the power supply, and we may utilise a mounting point here for the radiator. That's something we have to figure out, how we're going to mount the radiator.
Yeah.
But that's easily done, and if we can do it all from this back panel, it's easier for us. We only have to machine one panel then.
Yeah. Yeah, I agree. I think that is the best way. So, I mean, the back panel will probably just, for the sake of testing and prototyping this, we'll just cut out most of this just so we have we still keep the little thumb screw that holds this to the rest of the case. And then we've got freedom to move the rear I/O around however we want to. And then once everything is built, then we can fabricate a new rear panel.
So looking at the case, we've got three major components to the case. It's this base.
The remainder of the case.
Yeah, the central chassis of the case.
Yeah.
This base I'm quite happy with. I love the way it fits the outer skeleton. So other than a few venting holes for airflow, we're going to leave this piece mostly unmodified. However, we do need to move this central spine over. And if we look underneath, the central spine is only mounted by these two screws. So we only have to drill another hole, offset it, and remount it there. First, we need to measure up how much space we have here between the top of the GPU backplate and the side panel.
Because every millimetre counts.
So I'd like to get it back in, and then we can have a proper measure.
18.73. I'll do the bottom as well. 18.5. So if we call that 18.5 minus the thickness of the case, which is 2.5. So 18.5 minus 2.5 is 16. Minus 1 for tolerance is 15, minus 2 for a riser cable, 13 millimetres. So we want to be shifting the central spine this way by 13 millimetres. I think. Do you agree? Is my maths all right?
I trust your maths, Felix.
Okay. So we've made some modifications to the case. We've moved this central spine along by re-drilling the holes in the bottom. So they're 13 mil further along. And then I've also spent some time with a Dremel just cutting this away so that the cutout for the I/O is much bigger to allow for the moving motherboard here. But what we've just realised is we've just put this riser cable on where it would be, and I think, well, I'm pretty certain that it's going to interfere with the case here. So I'll try just putting it in and see how far off we are. Yeah, we're miles off. Okay, so that looks like maybe 10 millimeters too high. If you look down here, I don't know if you can see in there, but below the motherboard, there's a good amount of wasted space here. So we can shift this whole assembly down by a centimetre or so, or basically till the motherboard hits the bottom of the case. And hopefully that will allow for this to fit inside here. If it then still doesn't fit, then we might have to go back in by a millimetre or two until this does just fit in here. And then we'll be certain that we are making the best use of the space on this side of the case. So next up is going to be to modify this central spine again to allow the motherboard to be a bit further down. I think the easiest way to move this down is, first of all, we'll have to cut this cross beam out of here as well, so a bit more dremeling and filing there. And then we want to adjust this spine, and the easiest way is probably to add another bend here. So we'll take this off, probably flatten out the existing bend so we've got some material to clamp to, and then add another bend about here. And then we will drill and tap new holes to mount it back to the bottom piece, and hopefully it will fit perfectly. So I have straightened out the original bend. I've then marked 10mm down where we want the new bend to be. I've also drilled and tapped new holes to M4, so they'll be slightly bigger than the original holes, so we can use a slightly larger bolt for a bit more strength. And now I'm going to attempt to bend this along this line that I've scored here. So we've reattached the modified bracket. We've got this new bend in here. We've got everything mounted as we intended. It's a bit wobbly, so I'm holding it up for now. But we still have a slight issue, which is that the riser cable doesn't quite fit. So I'm thinking we've probably got enough material in this plastic piece to just file the edge off. Moment of truth. You ready? Oh, look at that! That's awesome.
Good job. That is a snug fit.
That's a very snug fit. I'm liking that a lot.
So that is the motherboard side of the case completed, for now at least. We've got the riser cable, the monoblock and the motherboard all spaced as we want them. The gap between the riser cable and the edge of the case is just a fraction of a millimetre. It's a very snug fit. So the whole reason for doing this was to open up more space on this side of the case. Because over here, this is where we're having the radiator and fans. And as you can see, there's not a lot of space, even after the modifications. We've got two 25mm fans, and there's not a lot of space here. We're thinking of using the radiator as an intake. That means air will be coming in from the side panel of the case, and then we'll be exhausting it out. But the problem with the case is there's not much ventilation for that hot air to get out. There's nothing along the top panel, and there's nothing along the bottom panel. Therefore, we're probably going to have to put fans, exhaust fans, on the top of the case. Otherwise, this hot air has got nowhere to go.
We've got the space though, haven't we? There's plenty of space above, well, not plenty, there is some space above the radiator and the block to fit a couple of fans on the inside.
There is.
So that won't be an issue.
So come over here and have a look. You can see there's not much space here on this side of the radiator, but that's fine. You've got a couple of mil, so I'm not too worried here. But if you come over this side, the fan is pretty much touching the center spine of the case. There is a gap between the spine and the motherboard, but that's only 6 or 7 mil. There's not a lot of space. And if I just slide this out again, you can see there is more space here. I'm yet to put in the power supply. In fact, we can do that now just so we can eyeball the space.
Yeah, let's see it all laid out.
My initial impression is that we may have to go for either a thinner radiator or thinner fans. I didn't want to have to downsize the cooling. There's a chance that perhaps we'll keep the 25mm fan on this side of the radiator and use a slim fan here instead. But these are all things we can test. At least we know it fits. There's a bit of wiring and plumbing still to figure out, but the main components, they're in.
Yeah, it's definitely going to work. What's the space like at the other end, like before the back of the case? Yeah, that's good. So yeah, we got some space for, well, the inlet and outlet ports are currently here, but they'd probably be this end, just so we've got the space to play with. Or the whole radiator will be shifted this way slightly.
I can spin that around. It's going to be tight.
It's going to be tight, but that's the fun of small form factor builds. But yeah, I like your idea of having a thicker fan there and a thinner one there potentially to keep the thick radiator. I think we're going to have to do some research or even some testing to see whether thick fans and a thin radiator is better than thin fans and a thick radiator for any given overall thickness.
Well, it's better to have more surface area. So if we could get 2 thin radiators in, it's better than having 1 thick.
That's an idea.
So this is where we left off, with a 54mm thick radiator. And as you can see, we do not have much gap in here for the hot air to escape.
I mean, we were thinking about having fans on top, weren't we, to kind of suck the air out, but still...
It would help, but we don't really have much space, height-wise. But having more fans is a good idea. The alternative is to simply go for a thinner radiator. You can see over here we've got a 30mm thick, and this does a much better job. You've got more space for the hot air to escape, and often having a thinner radiator is better in some ways. Your fans don't have to work as hard, they'll be more quiet, and you don't lose that much performance.
Yeah, we looked into this a lot, didn't we? Like the difference between something like a 54mm radiator and a 30mm radiator is actually tiny. The vastly more important thing is the surface area on the front of the radiator.
Yeah.
So
this area is more important.
So this 280mm radiator and that 280mm radiator, which is thinner, are going to be very, very similar in performance. So by reducing it, we wouldn't really be reducing the cooling performance that much.
Sure. In a perfect world, you want more thin radiators. This adds complexity because you have to plumb more radiators, but we decided to actually go that route, haven't we?
We have. So,
look at all of this. We have 1, 2, 3 radiators and 5 fans going into this build.
So 1 radiator with 2 fans. We've changed to 3 radiators with 5 fans because we love making things incredibly complex for a tiny improvement, and we think this will be a tiny improvement because we're going to have a bit more surface area. So the goodies that we've got in store for you today are a pair of 184mm radiators and a 120mm radiator, which is very, very thin. So we've gone from 1 thick radiator to 3 thinner radiators. But this works out as more surface area across these 3 radiators than we did with the single 280mm. So just as a quick comparison, here is the original 280mm radiator laid out next to our new radiators, and you can see the difference in surface area. There's a lot more surface area than here. Well, not a lot, there's about 10% more surface area with this collection of radiators compared to this one. So this is the layout that we had at the end of the last episode, but what we're going to do is instead mount the power supply much closer to where it was originally designed to be in this case, and that has the added benefit of us not having to run the kettle lead through the case out the back. It can just be used directly from the back of the case. The pump will then go on top of here, probably somewhere like that, and then we have our 284mm radiators, and we're going to have one here and one here, And then we take our single 120, and that is going to go here. So why are we doing this? What's the advantage of this over the previous layout? Well, you can see that this will actually be floating about here. You can see that the fans have so much more space now for the hot air to come through and not immediately hit something. And we're not going to be pulling in air from both sides with this setup. This radiator is going to be exhausting air. So all the fans and all the airflow, they're going in the same direction. We've got air coming in, we've got water being cooled, we've got the hot air coming out, and then this fan is helping that airflow. So it's going to be a lot easier on the fans. They don't need to do as much work to be pushing air in places it doesn't want to go. And it's just going to be a much nicer flow through of air. So we think the cooling here, the idea we've got for the cooling is going to be not significantly better than the other idea, but it's going to cool it better. And that's so important because we're using such a power-hungry CPU and GPU. And this probably brings us on to a good point to answer a couple of questions that were in the comments. One of those being, why are we using an Intel CPU for a gaming PC when it puts out so many more watts than an equivalent AMD CPU that will game just as well? And the answer is, it's not a gaming PC. It's an everything PC. We've gone over this in quite a lot of detail with the customer. They use it for gaming, and that's why we're using a 4090. But they use it for just general other things as well. It's a workstation. They do video editing, they do photo editing. They do all sorts of things. So with this combination of CPU and graphics card, this is the best possible PC for their use case. And then the other question that we've been asked a couple of times is why we've chosen this case. The primary reason is because this is the case the customer wants. But there was a lot of discussion with the customer about what they're going to use this PC for, and they want it as a travel PC. They want to be able to put it in a bag, carry it around, and take it between various places to work. And a lot of the other cases are made from multiple panels joined together, and they're not particularly strong. But with this case, it's one continuous piece of metal. It's so much stronger than any other case we've ever seen. It's 2.5 mil thick, aluminium, bent round, and it's one piece. There is no risk of the corners bending up or bits getting caught on bits of fabric if you're putting this in a bag or something. So for this customer's use case, this PC and these combination of components are perfect for them. So that is why we are using them.
So the next step for us to do is to extend this central spine on the case. The spine is the piece that everything bolts to. The motherboard and the radiators will eventually bolt to that. If we take this, you're going to have a radiator on either side. Everything bolts to this. Now, I think the best thing for us to do is to make a central spine out of wood to begin with. That way we can get our mounting holes and everything correct. We can mess around with wood a little bit. And in case you're wondering, you can't bolt anything to the side of the case because you need to be able to slide the central chassis in and out of the outer housing. That's why everything has to be bolted to this piece. You cannot bolt anything to this piece, otherwise you'll never be able to slide the components in and out. So we'll be replacing this metal piece with a wooden spine that extends the full length of the case. We'll be using this bracket, bolting straight through this into the wooden board.
That's the same bracket that is already on there that the monoblock is mounted to.
Then we've got to figure out a way to mount the radiators to the central board as well, because we're currently using these holes to mount the fan. So we'll have to put a nut and bolt through there.
Yeah, some kind of spacer.
Yeah, we'll figure that out.
And then obviously we'll cut a big hole in the wood. It's not going to be a solid piece of wood. It'll be mostly an outline of the shape of the case, really, so that all the air can still flow through the middle.
Is there anything else we need to bolt to the central spine? I think that's it.
I don't think
what
so.
About the pump? The pump itself?
The pump, yeah, the power supply is attaching to the back of the case, to this piece here. But yeah, the pump,
the pump, we can use these to bolt here onto the wooden board, can't we?
Yeah, that way the plumbing is facing in the right direction.
We've got a nice bit of oak we can use.
We do. I have some oak in the cupboard, actually. But yeah, if the pump was mounted to the back of the case, then the plumbing is never going to be facing in an easy direction to do anything with. So yeah, that needs to mount to the central spine as well.
It's a nice looking pump top, Felix. Where'd you get that from?
Top secret.
So, we've cut some wood to size. This is a nice bit of oak. This is going to be the central spine for our case. What we've got is 3 holes here. These are the ones that we drilled out in the last episode. We're probably going to turn them into slots so that we have some adjustability to where we position the spine in this direction. And to get this spine mounted to here, we're going to use these little brass inserts. 3 along there, 2 along the back, which gets us connected to this face, and we'll take it from there. We have our board fitted, and the motherboard and monoblock are mounted to it, and it just about slides into the case. It's a very, very tight fitment, he says, as he pinches the cable. Now we've got to fit the radiators, and because we've gained some extra height having 2 radiators stacked on top of each other, you can now see we're not making it under this corner. We're interfering with the edge of the case. So we've got to lose about 5mm. That can be done by thinning out this central spine. We can also sink the brackets. If you come in here, Felix, the back plate of the motherboard, we can sink that into the central spine by chiselling out the wood. That'll gain us 3mm. We also have, every millimetre counts here. We have 2mm on the heads of these bolts, so we can lose them.
Oh, because we'll be bolting it in from
the other side.
This side. So the head of the bolt will be on this side. Yeah, so the fan will be flat
so
against
that's
the wood.
about 5mm.
Obviously, we'll have cutouts in the wood for the fan. It's not going to be like right
and
up
it's
against
still
it.
going to be very tight. I'm not sure if this is going to fit. We're going to have to get creative.
I am optimistic, but obviously, yeah, small form factor builds, huh?
I know, right?
I think it'll go.
We've got to make it go.
But yeah, so I guess next thing is then to chisel out where the monoblock backplate is, sink that into the spine, and then because we got the slots on the bottom, we probably didn't explain that very well, that allows us to shift this spine over by 3mm, which is how we'll gain that depth on this side rather than bringing the monoblock in. So I'm far from a woodworking expert, but hopefully this will look acceptable, at least for prototyping purposes. So that's probably one of the worst chiseling jobs I've done for years. Ended up actually cracking the wood, glued it back together, and it's fine for, I mean, this is a prototype to get the fitment right, so it's not super important. But I think if we do this again, I'll probably buy a router and do it properly. Anyway, the back plate is now sunk into there, as you can see. So now, if we put the motherboard on, we've gained a few millimeters. You can see how low the board is to the panel now. So let's put this back together. Okay, so everything is sitting roughly where it would go. The radiator would be down this end. But unfortunately, I slide it in and we're still maybe 3 millimeters overhanging that edge there. So this is 12mm thick wood. We probably need to go down to 9mm and remake that central piece.
Okay, we've now got our 9mm bit of MDF with the bracket inserted. We've got a recess, so it sits pretty flush with the board. And we're now going to mount this and see if those 3mm we've gained is enough to fit the radiators into the case. Okay, the board is now fitted inside the case, and it is now the moment of truth.
If this doesn't work, I'm not really sure how we can lose any more width. Oh!
It's going.
Watch out for the cable.
Well spotted. Let go. Look at that. There's
Oh my god, I'm so happy.
no space on either side.
Go on, just push it all the way in, check it fits.
Should be very careful with this riser cable.
Oh, that's such a relief. I really didn't want to go down to 6mm MDF.
Okay, there's a few more modifications we've got to make to the case before everything is going to fit. Firstly, we need to chop out this upturn on the bottom of the case, just so we can sit the radiator and fans, remember, down as low as possible, because currently the radiator is going to sit on top of this upturn. So we're going to chop all of this out from here. Similarly, there's an upturn, if you come around on the inside of the case, there's a small upturn here. It's only a mil thick, but we need to cut half of that off so that the power supply sits flush with the rear of the case. Another thing with the power supply on the rear of the case, at least for now in this prototype, because remember we're going to make a new rear I/O panel for this case, but for now we can't get our kettle lead in, and we're also hiding the power switch. So we're going to make a cutout for that. Okay, the cutout in the power supply has been made. We've removed that upturn there, the upturn along this length, and the final two lugs have also been removed.
So we've got the case assembled again, or the inside of the case. And the next thing is just to mark up where everything goes. So we're going to temporarily mount the power supply, figure out where the pump's going to go, mark out the holes for that, and then start marking out the holes to mount the radiator and the fans onto this side, and then the other radiator and fan onto this side. So we spent several hours meticulously marking out and then drilling every single hole that we will need to mount everything to here. And it's time for the full assembly. Okay, so it's nearly midnight and we're ready to call it a day, but we're very happy because we have everything assembled and in the case and it fits. So that's really good.
Shall we take a look inside?
Let's do it. You got it.
This is it. A PC with 3 radiators, a monoblock, a pump and a power supply, all mounted. Okay, the power supply is not mounted, but we need to make a rear I/O panel for that.
But everything else is mounted, the pump is fixed, the radiators are fixed, all 3 of them.
Wow.
And it looks so cool.
Yeah,
It looks so cool.
it's solid.
I'm so happy with how that looks.
Now we've got a little bit of space left over because our customer wants a 2.5-inch drive.
Yep, as well, yeah, so that'll fit here or here. There's lots of little awkward gaps of space that we can squeeze that into.
We'll have a look at the space alongside the power supply for the cables. we did test some cables in the power supply. You've got just about enough where I'm happy we'll be able to get all of our cables into there. So this side of the case is nice and tightly packed. There's no real wasted room. Plumbing, cables, it's packed. Over here, we probably have space for a drive above this radiator. There's going to be a lot of plumbing to do as well. So I think in the next episode it'll be wiring and plumbing.
Well, before that, because this central spine is still a solid piece of MDF, we need to spend a lot of time making holes for all the airflow, because we're going to be cutting out almost all of this, leaving just the locations where the bolts mount, so there's lots of airflow going through it. And then also the outside of the case,
oh, that's true.
Obviously this isn't even close to enough airflow, so we're going to be chopping almost all of both sides out, I think, or at least where the radiators are. So we've been talking, and we're probably going to be chopping out almost all of both sides, because we obviously need a big hole where all the radiators are, but there's no real disadvantage in just having a much bigger hole over this whole side. We've got the power supply over here as well, which could probably do with some ventilation to it. That's the intake here. So yeah, we think we're probably just going to chop out most of both sides and then fabricate some kind of cool looking vent mesh type thing.
And we've got some ideas.
We've got some ideas, yeah, which we will get to later on. Right, so this is the central spine, and it's a bit confusing because there's lots of holes everywhere, but these radiators sit here and here on this side, and on the other side the 120mm radiator sits about here. So these 4 holes are for the 120mm radiator, and then these 8 holes are to mount the 2 of these radiators. So we need to figure out the way that we can remove the majority of this while keeping the screw holes intact and keeping the mounting points strong enough. So we can't cut away everything, otherwise there's nowhere for some of these screws to attach. So we're going to figure out the best way to do that. Right, so we've got these points marked out now, and those are the bits that we have to keep intact. And obviously these can't just be floating, they need to join to an edge somewhere. So the motherboard sits here, and one of the fans is going to sit here. So if we use that as an edge, then we're keeping all this, and we probably want to keep material around the perimeter as well. So I'm just going to take this 12mm bar and just mark out 12mm from every edge. And we're starting to get a picture of what we're going to cut out. So we're keeping all of this, we're keeping all of this, we're keeping all of this, and we want to chop out most of this. So we basically just need to join these 2 bits to an edge. So what do you think, Dean? Just straight like that and straight like that?
Is it going to be strong enough? Perhaps we should have one going straight across like that.
We could do. We're then blocking a lot of the edge of the fan. I think it would be strong enough. I mean, it depends what material we end up making this central piece out of, because it's obviously not going to be MDF. But I think even in MDF, that would be strong enough. There's one way to find out. Let's give it a go. Yeah, let's do it. Okay.
What do you reckon? Just something like this?
You thinking like that? Yeah, I guess we don't want a sharp internal corner. You don't want sharp edges, yeah. But then the more material we add, the more of the fan we're blocking.
We've got to find the compromise between the blocked airflow and the strength of the material.
This edge is right on the join of the fan, so we could keep that straight like that, and then kind of curve that around like that, something like that. What do you think?
So you could still use more of this area as well.
Okay, let's follow that around. It's about there.
You haven't blocked any of the fan with that line.
Yeah, you're right. You're right.
So you could even come further this way, so you're blocking 2 fans equally. It should be better than blocking 1 fan and not having any obstruction on the second fan.
Yeah. So if I just draw that out, yeah, so we can go to there.
You can overlap that. You can do even more if you're going to block. We're blocking some of. Mark this one out as well. Just put the fan on this side and let's see how much we're blocking. Nice. Do you need a new pen?
No, we're good. Right, so that line there is the curvature of the inside edge of this fan here. So ideally we don't really want to cut out, we want to avoid cutting out as much of this as we can. No, we want to cut out as much of this as we can, sorry. So maybe we just go like that, because I think that's still going to be strong enough. Cutting that out and cutting that out.
Nice.
Okay, so then we just need to do this on the bottom as well.
Nice.
So that's what we're cutting. We're cutting all of this area to leave a nice big hole in the middle. Let's do it. Jigsaw time.
Okay, we have our spine cut out, and we'll take a look now at how it's going to affect the airflow coming through the radiator. We've tried to minimise the surface area that we're covering. As you can see, we do have these 2 supports which are covering a fair bit of the radiator, but around the edge I'm happy. We're not losing too much surface area. So overall, a good result. Let's take a fan and see how that looks.
Looks good to me. What does the fan look like from the other side?
What do you want to see, like this?
Yeah.
I suppose this is the important one to have a look at, isn't it?
Yeah, that's the most restricted one. That's fine, isn't it? Yeah, that looks good to me.
Not too bad at all.
Very nice.
Okay.
So what's next? Build it back up and have a look?
I think so. Let's try and have a quick look with this radiator and how it sits on its mounting holes. Let's go something like that for now. So that radiator's
That's
going to
great,
sit like
barely
that.
covering any of that.
Okay,
I'm very happy with that.
good job. Let's put it all back together. So our spine is cut out, we've mounted the radiators, so you can get a good look in there at the intake radiators and fans. So air will be coming in, because this confused a few people in the last video. This radiator is an exhaust, which means the airflow is coming from here and exhausting through here. So we will be passing some hot air from this radiator through this radiator, but we've got an idea for this which will be coming in a later episode. But for now, we've got a cutout in the central spine. We now need to have a bigger cutout in the case. Where is the case, Felix?
The case is here, sir.
So, rather than just have a cutout here where we need it, we're going to go for a symmetrical, a consistent finish across the whole side of the case. So that would mean cutting out a slot like this.
I'm going to keep pressure here to keep this flat so we don't fall over the edge, and then I think we're just going to have to file it for a couple of hours afterwards.
That's not fun.
You ready?
Go for it.
I'm going to go very slowly because this might not work. I'll try. Okay. I need some ear protection.
Mm-hmm. Me too.
From the headphones. Oh my god, it's exhausting. Oh, I'm putting so much force into it. I just wish I could lock this on, but I can't. Alright, carrying on. Mate, that has worked really well. If anyone was wondering, the ideal tool for cutting a hole in a John's Boat N1 NAS case is a Makita jigsaw.
That is a hole.
That's a hole. I think I've successfully stayed just inside the line everywhere. And yeah, so we just got to file it down now until it reaches that line we drew. I'm pretty happy with that. That's gone well. Hey guys, it's the next day and we can see that in the daylight, the cut we've done still looks pretty good. I'm pretty happy with that. So I'm just going to bring the cut edge much closer to the line using a flat file, and then hopefully we'll have a very neat, perfect rectangular cutout. So that is the first side cut out, filed and sanded a little bit. So we're just going to peel the tape off now and see how good of a job we've done. How do you think it's going to look, Dean? Professional?
I trust your filing skills. Looking pretty straight and true so far. Nicely done.
That corner's a very small curve to it. Not quite square, but that's good. I'm happy with that, at least for the first attempt. Right, so we have now cut out both sides. Very happy with that job. Looks very neat. Do you like it? You happy?
It's very straight. You did well.
Thank you. It's not fully sanded down or anything, there's a few file marks, but I think it's looking pretty cool.
Should we take a look? See how the radiators fit
Yeah,
inside?
let's do it. Nice, yeah, good.
Very careful with the white paint,
Mm-hmm.
I want
That's
to see
the
here,
important side.
because this has got the most airflow, you've got the power supply and the tube radiator.
Yeah, that's looking good.
It's great. We're not losing too much at all of up here. We've covered the radiator a little, but we got
Such a big
10
gap.
mil between
Yeah.
the fins and the side of the case.
Yeah, I don't know if you can see that on camera, but there's a gap there.
No, I'm really happy with that.
Me too. That looks awesome. So now we need to decide what to do with the grills and with the case. And I think we should sand all this off and polish it. Mandalorian style.
Mandalorian style. Well, I've already got a bit over there. While you've been working away on that, I've been polishing this down.
That looks awesome!
What do you think with that?
I think we should do it. What do you think?
Yeah, I'm up for it.
Yeah? Pot noodle for you, sir.
Cheers, mate. That'll keep us going.
How's the sanding going?
Slowly but surely.
Oh, it's
We're
hard
going to
to
need
see
a
in
lot
the
more
light.
pads. We're going through the pads quite quickly and we're running low.
Okay,
But we're getting there.
I believe in you. Yo, that looks crazy.
It's getting shiny.
That's so cool. Are you glad we ground all the surface off it?
It wasn't fun doing it. It took me ages to get all of that off, and it's not all off. So we'll definitely have to come back to it to finish it. But for now, just to have a look at what
Gives
it
us
looks
an
like.
idea,
It
doesn't
gives
it?
us a good idea. Okay.
Man, this is gonna look great.
Now, to make the side panel, we were thinking about doing speaker grills or a mesh, but none of that's going to be strong enough. So the idea is using these rods. They are 6mm aluminium. We're going to cut them down to length, and I'm not sure yet whether they're going to go inside. We may not have the space, or if we're going to go outside. But I think you're starting to get the idea of what we're working with.
And the good thing about making them out of round bar is you don't have sharp corners that are gonna make turbulent air, like any air coming.
Like if these were
Through
square
those.
profile.
Yeah, if they were square profile, you got sharp edges, so the air's gonna come through and become all turbulent on the back side of the square, but with round bars.
And we have freedom of how much gap to put between these. So let's cut these down to size, flatten off the edges so that they can locate onto the case, and we'll show you what that looks like. Okay, this is one of the bars cut down. You can see the lip we put on it. You see that all right? The idea is to sit them on here like this. Or, this is what we originally thought. We originally thought on the inside would look better, because you can hide the weld or the glue. It's likely going to be weld on the inside. But after trying like this, I think we both agreed that looks better.
Yeah, we both thought the inside would look better because it would be more minimal, but after putting them on the outside, it just looks cool. It's kind of like a grill on like a 60s car or something like that.
There you go. That'll give you a good idea of what it's all going to look like. What do you think?
I love it. It doesn't look like any PC I've ever seen before, and that's why I love it.
Does it look a bit like a toaster though, or a grill?
Yeah, but like a really cool toaster.
Like once we got the PC running inside here, you can put your bacon on top, maybe cook some eggs.
And this is on its side, remember, this is the side
Yeah.
panel, and we do the same for the other side.
It'd be nice to slide the PC in to have a look, because I want to see what this looks like behind this. Do you think we can do it whilst it's laid on its side? So we've run out of time here today. So this is about all we have time to do. But the final concept has taken shape. Like you said, it's unlike any other PC case I've seen.
But yeah, let us know what you think, guys, because we'll probably weld these from the inside, so it's fairly hidden. We'll obviously equalise the length of all these. This is just kind of just a rough attempt at seeing what it would look like. I think we maybe need one or two more of these.
Do you think so?
So yeah, I think it's a bit too gappy personally, but I don't know.
There is one more. This was the slightly shorter one. Is it worth us trying to squeeze that one in now?
Give it a go.
This one might actually have to go in the middle. There we go. Yeah, we're going to have to get these perfect. It's very easy to see when you're a millimetre out.
Yeah, we'll make a jig of some kind. And then maybe learn to weld as well. Because they say we're going to weld these. Neither of us have a welder. But we know people.
It can be done. Okay, there you have it. Okay, so this is what we thought looked good. We got 11, 12 bars across here. I felt like, and you agreed, more bars looked better.
We did, yeah. We both agreed on that. The customer, however, thought that they asked for 5 bars. They saw the video and they said they liked the concept, but can we have fewer bars? We did warn them that there's a much bigger gap, so you're more likely to, dent bits of the radiator fins and stuff like that. But they were happy to take that risk, and they like it like this. And
with 5? Can we
this is 6, isn't it? Sorry.
Is this 6? Can we
so they originally said 5, and I said,
can I add another one?
Yeah, I said basically I think that's not quite enough. Can we go to 7? And it still looks really cool. I'm perfectly happy with 7.
Yeah.
And
Did they give their reason why? Was it a taste thing?
It was entirely a taste thing, yeah.
It's not like they were hoping for more airflow. It will give more airflow, but...
It will give a tiny amount more airflow, yeah. No, it was entirely their own taste, and this is their PC, so that's completely their call. I think as long as we don't actively dislike what they're asking for, I'm perfectly happy to go with their recommendation.
But it's still the same look. It hasn't fundamentally changed anything. So next step, get it to a welder.
Yep.
And get them fixed in place.
Yeah, and yeah, our welding skills are not good enough for this. This is a very thin piece of material. The accuracy is so important, and we've both done like a little bit of MIG welding on our cars and stuff, but we've never really done this level of like accurate TIG welding, which is what's going to be needed. But before we find ourselves a welder who can weld this up for us, we have a bit of work to do. And that is because once everything is welded, it's going to be very difficult to polish the slats, neaten up the ends. So everything needs to be fully finished and polished before it's welded. Also, some of the slats aren't exactly the same length. Some of them vary by a millimetre or so. So I'm going to spend a bit of time just making sure everything is neat and everything is fully finished as we want it in the finished product before it is then welded together. So let's do that. Right, so everything is exactly the same length. I've added these markers to show what order they're in. And then this little arrow here is just going to show that they're the correct way round. And then one more thing I'm going to do, because these all have a tiny bit of movement in them, just so they line up. I'm going to put an arrow on each one to show which end it should be pushed up against for the ends to be perfectly lined up, just to make everything easier for the welder. So that needs to be pushed left to line up. That needs to be pushed right. That's right. And then all of those are wedged in. And then the final thing to do is going to be to do something with these ends. Now I'm thinking a chamfer along the edges might look nice, and just kind of tie it all together. Yeah, let's do a chamfer. And I think rather than trying to do these on the disc sander, where one slip and I've ruined it, I'm just going to use this piece of sandpaper, use my finger to align it on the flat, and then that way they should all match nicely. Okay, there we go. So you can see now that the ends just look a bit more finished. So when they're welded, you won't have kind of the end of a cylinder sticking out the end. You'll have that nice little detail there. When I cut these, I just did it by hand with a hacksaw. So the end of these, that little remaining rectangular end face, has the finish that you get from cutting something with a hacksaw. So now I need to hold each of these pieces on their end and just finish them off probably with 600, and then let's go 2500, that's probably enough. Then I will polish them on the linishing wheel just to kind of round over any edges and deburr them in a nice efficient way, and then I will polish them. So let's go again. Nice. Right, now it is polishing time. I mean, they're not quite going to be jewellery level finish, but should be most of the way there. So I'll get my trusty sock, and I think I'll do all the ends first and then do the shaft part afterwards. That's come up really nice. Right, I'm not going to make you watch all this. Let's skip to it being done. And there it is. Obviously that polished off all my useful Sharpie markings, so I had to take a note of which one I was doing and then draw it back on afterwards. Let's see how this looks. I'm really happy with that. As I said, it's not quite jewellery level, but pretty close. Now, obviously, all of this test fitting has left scratches on the case when these had little burrs on the end. So I'm just going to quickly refinish these surfaces, and then it's welding time. Right, so I'm on my way to a local place called the South London Garage in Mitcham, and there's a guy there called Steve who builds custom stainless steel exhausts. He's a really talented welder and fabricator. He made an exhaust for my MR2 a couple of years ago, which I'm really happy with, and I had a quick chat with him about the case project, whether he can weld aluminium, and he can weld pretty much anything, so he says it shouldn't be a problem at all. So I'm on my way there to see him now. Let's see what he's got to say. How you doing, Steve?
Not too bad, not too bad. How you doing?
I'm all good, man. So, what are you thinking about our case? Is it going to be a tricky job?
It's going to be a little bit tricky, but doable.
How long have you been a welder for?
God blimey. Probably been welding since I was about 18, and I'm 48 this year, so coming up 30 years.
Wow, okay, so you're definitely the man for the job.
Yeah, on aluminium is a bit more forgiving, in my opinion, than stainless steel.
Right.
You can play with it a little bit more. But being the gauge, what we're welding today, it will be, delicate.
Yeah, okay. So Steve and I were staring at this for a good 20-30 minutes trying to figure out how to accurately align all these slats.
Just trying to think out of the box at the moment.
If I'd planned ahead, I probably could have 3D printed or laser cut some kind of template that would sort of fit over the top of them all and hold them in the right place. We tried measuring it and we couldn't get it accurate enough.
So the space between that and that, it won't work like that.
But Steve figured it out. So Steve, absolute genius, has realised that the gaps we need are exactly the width of electrical tape. So he's marked it all out with electrical tape. Because that was the main thing I was worried about, is how do you get the gaps even? And he's figured it out, of course he has. After that, he had to sort out a way to hold everything in place while he welded it. He tried a couple of things and figured that out as well.
No. Plan B. There's always a plan B. Why does gaff tape never rip nicely when you want it to? That's the one, isn't it? So yeah, we attach the earth to the cage, clean the tungsten so there's no impurities on the alloy. Got some alloy feed rod over there which I'll gently melt into the joints.
Amazing.
And then hope it all goes well.
Me too, Steve, me too.
I have faith, don't worry.
Got the mask.
Let the fun commence. It's PFM.
It's what?
PFM.
What is PFM?
Pure flipping magic. I think this is probably the most scariest thing I've done. Being know how delicate and one time.
Completely irreplaceable it is.
No pressure then.
Yeah.
Irreplaceable on the last 6 welds. Still no pressure. That does look really cool.
Amazing job, Steve. Was it harder or easier than you thought it would be?
A little bit nerve-wracking knowing that it's a one-off,
Yeah.
but I'm always up for something.
You've done an awesome job. Thanks so much.
No problem at all.
That is a cool looking case. Now it needs a good amount of cleaning up and polishing. There's a lot of burn marks and yeah, various bits to clean up after the welding, which is as expected. But there's not really anything else to do with the case now until the final assembly, because we're just going to scratch it up more. If we get it fully polished now, we're going to be continuing to put the internals in and out of it and just scratch it up more. So this is done until the final assembly, at which point I've probably got several hours of polishing to do on it. So it's now time for arguably my favourite part of any water-cooled build, and that is the plumbing. And it's going to be pretty tricky, because look at the inlet and outlet ports on the radiator, and then the ones on that radiator. There's a lot of piping to go in lots of places where there isn't space. But I can definitely do it. Let's do a little dolly zoom. That wasn't bad. All right, plumbing time. And I've been staring at this thing for maybe an hour, just visualizing where the pipes are going to go. And I think I've got a pretty good idea now. We're going to be doing this all in copper where we can. However, it needs to, we need a way to fill it with water. So we can't just plumb everything in, attach it, because there's no way for the water to get in. So one pipe is going to have to be flexible, I think. So I think I'll do everything in copper except here, the inlet of the monoblock to the outlet of the final radiator is going to have to be a flexible bit of pipe. So we can do everything else, undo that, bend that pipe out the way to be able to fill it with water. I mean, that in itself is going to be tricky without a reservoir, but it's doable. And we need a way to drain it as well, to flush out the coolant. So that flexible pipe needs to be on the outside somewhere. So if I have it on the top, we can then turn the whole PC over and undo it, drain the water out when we need to, without all that water pouring all over a 4090. So immediately, by far the most difficult part is going to be here, because we've got these ports going in and out of the radiator here, going directly into this piece of MDF. And even with the smallest possible fitting, right angle fitting, even if we could fit in that gap, which it looks like maybe 12 millimeters or something, the only place it can go is out this way, and that is the end of the case. It's just right over the end, so there's literally no space. So we're going to need to do some more modifications to the central spine. So I'm gonna basically project these circles onto there and then cut those shapes out. And then it's all going to have to kind of go along the top here or down the bottom here. That does mean that this bit of the spine is going to become fully separated, and that's not particularly important because the radiators are literally touching each other, so there's not really going to be any flex with the two ends of the spine kind of bending out like that. However, when I do the final spine, I will probably keep them all as one piece just by extending the MDF a bit further in, just covering a tiny bit more of the fan in order to keep this as one piece. So I'm going to mark that out, take it all apart, cut those holes where they need to be, and then the other thing to think about is the plumbing from the pump, because everything is this side except the pump. So the pump plumbing needs to go over this side, and we've got this nice little bit of MDF here, so I can just cut that out, and that will allow both of the pipes to come over wherever we want them, as well as all of the wiring, which comes from the power supply. So that's going to come out, go directly up, and the majority of it is going to have to snake its way over to all the components on the other side of the board. Right. hate using jigsaws. About 5 years ago I tore my fingernail clean off by trying to change a jigsaw blade and then accidentally leaning on the trigger. Right, there it is. There's not much of it left. But that should be everything cut away that was going to be in the way. So let's put it back together. So we're all done. You can see on this end there's very little left, and this little tab here, this little bit of MDF, all that's doing is holding the two ends of the radiator together. It's not actually supporting anything. But we have space now around those ports. So now, even though I've said this like 3 times, it's plumbing time. And I'm going to start with the easiest pipe, and that's going to be the outlet of this radiator to the inlet of this one. And if you're watching our other build that we're doing, you may have seen these fittings that we make. These are prototypes, but we've got enough for this build. And these are male-to-male rotary fittings. So we're going to have one of these in each port. And then we will have a 90-degree bend here and here, and they're going to be as close as they can to that piece of MDF. So they're probably going to sit about there. So let's cut these bits of copper that we need for this. So that's all the copper pieces cut for our first pipe, and it goes together like this. We've got 2 little small pieces that take the solder-in brass fittings. So one in there and one in there. They then go into the 90-degree bend, and because these brass bits fit in the inside diameter of standard 15mm copper pipe, this piece is essentially acting as a diameter reducer. So there's not really any pipe on show, and we're going to have to do 2 solders, the fitting to the pipe and then the pipe to the brass bit, but it should all kind of function as one process just by feeding the solder in. So that's there, and then that joins them together like that. Quick test fit, looking good, so time to solder. And the first thing to do is to flux the inner and outer faces of every single join, and we've got 6 joins here, so I'm just adding flux everywhere. You don't want to have any dry spots anywhere. Every face needs to be completely coated. So that is now all fluxed up and ready for soldering. And I'm going to be heating from this side and soldering from this side, and the reason that you do that is because you need to know that all the area where your solder is going to go needs to be hot enough for the molten solder to flow around it. So if I were to heat from here and solder from here, this side might be cold, and I might think I have a solid copper solder joint, but it might not have made it to the other side. So by doing it one side and the other side, you know that everything is hot enough, so your joints are going to be solid. Oh, I haven't done this in a few weeks and my hands were shaky as hell, so it's going to be a bit more clean up than I'd like on there. Anyway, that is done, and that should be very watertight. And there it is, installed. It actually interferes with this 120mm fan here, but we can just make these standoffs a couple of millimeters longer. We do have the space available here. You can see that the monoblock is actually further out than the radiator is, so we can bring this out by a couple of millimeters and we still won't touch the edge of the case. So I'll deal with that when we get to it. I think the next pipe I'm going to attempt is the one going into the bottom of here. And I think this might be the hardest one, because it's going to come from the pump, which will be up here. I've temporarily removed it. It's going to come out the pump, over the top, along here, down here, and then in. And everything about that is really difficult. The first reason being that if we have a pipe coming down the side here, there is just enough space. I mean, it sticks out more than anything else, but there is just, I'm talking within 2 millimeters, just enough space for that to fit. But that is then not perfectly in line with the inlet port of this radiator. So I'm going to have to do a little bend there, and it's only like 5 or 10 degrees. It's not a bend that you can buy a fitting for. So I'm going to have to get creative here. So I've been playing around a little bit and I've mocked up the first bit. So we want to go from the top bit of the pipe down to this side over here. I've mocked up this first bit, and something I realised was I was going to have this pipe here, but the rotary fitting needs space for this whole pipe to unscrew, and that just clears the radiator here to then screw in. And I didn't want to have to attach this before putting the radiators in, because the order of assembly would get to the point of being ridiculously difficult. So I've made it slightly easier for us when we assemble it. So I also need to, everything I'm doing, I need to think where other pipes will go, because the inlet of the pump needs to come out of the monoblock exit, go over the top and then down into there. And because of the fitting, it's not going to be right up next to the pump, it's going to come out to here. And then that's going to leave this space for some wiring. And we may need to punch some more holes through the central spine to get the wiring through. Anyway, that's there. And then over this end here, the downward pipe needs to be touching, literally touching this fan to fit. And there's a little kind of groove in the middle of the fan, and it needs to sit within that groove. So it has to go here, not there, here. So the pipe's going to go down there, which means that this pipe is going to come along here at some point, go over there, and then go down. So I'm thinking something like 245s will do that, with enough space to clear this inlet to this radiator, with a 90 there, and then join here to here with a pipe. So I'm going to solder this first, because trying to do everything at once is going to be way too hard. So I'll solder this, then we'll continue it bit by bit. So same as before, we're just going to flux everything up. I'm trying to take note of where the logos are on these fittings, because I want them hidden, I want them facing down whenever possible. But something to bear in mind is you can't, if you're soldering in pieces like I'm planning to do here, you don't want to solder one half of an elbow and then come back and do the other half later, because it's incredibly difficult to do that without remelting the original join. So when I said I was going to do this little run and then add the pipe later, I'm actually going to add the pipe now and then chop it down to length, because otherwise I'd have to come back later and solder just the pipe into the fitting that's already soldered on the other side, and that would compromise the join. And because this particular pipe run has no three-dimensionality, if that's a word, it's all flat, the best jig is my anvil, because it's just going to keep it flat. Although I do want to lift this end of the pipe up to account for the thickness of the fitting that's going to go into the other end to keep that flat. So I'll get a bit of something just to hold that up. That's my bit of something. A piece of copper, which is actually made from a cut and flattened copper pipe, so it's the perfect thickness. Just going to flatten that. Can you really call yourself a PC builder if you don't have an anvil? Again, not the best job, but better than the last one. I seem to slowly get better and better throughout a build until at the end I'm pretty good, and then the start of the next one starts all over again. Not terrible. And here is that piece back on. So I've mocked up the next bit. So I've got a 45, a 45 and a 90, and again I've got an oversized bit of pipe, so I'll be chopping it down later to allow me to solder both sides of every elbow here. So I'm going to align this where I want it, which is touching the fan, and use that as a template to mark out where I want to cut this pipe. Perfect. Perfect. Let's see if it fits. Oh, it's looking good. Oh, amazing. Yep, that's worked out brilliantly. It's exactly where I wanted it to be. Okay, so next is going to be to add a 90-degree bend here and then figure out how to get that to line up with the bottom of the radiator. So there I've cut the downpipe to length, I've got the 90-degree fitting on the bottom, but you can see the very slight offset that they have. So there's a little bit of an angle there, so I'm thinking I need to get some pipe like that, but it's going to have to be bent slightly, and it's way too small to try and bend it through any normal method, so I think I'm going to have to resort to hitting it with a hammer. Right, so this is my plan. I've got my little bit of copper with one of the brass fittings in one end, which is going to be needed to attach it to the radiator. And then I'm going to put another one in the other end, and that's going to act as like a die to keep the pipe circular. Then I'm going to whack it in the middle, put it on some wood, whack it in the middle with a hammer, and that should add a little curve, but because there's one of these in each end, they will keep it pipe shaped, so I'll still be able to solder each end. That's the plan anyway. This is not working. Right, plan B is to do basically what I did before, but with the fitting included, so I can kind of bend that and the pipe. But if I do that, I might permanently get this wedged inside here. So in case that works, I'm going to flux it first, then I'll be able to solder it once it's bent, rather than having to then remove it and put it back in. It doesn't look amazing. Nah, still looks like shit. I'm gonna start again. Desolder. So I forgot that this exists. So I got one of these. I'll just chop it here, put a little bend in here, and then solder this to the inside of that 90-degree bend, hopefully. That should do it. That's so much better than before. I'm so glad I didn't settle for that bodge job that I did before. Right, let's get this soldered. I've never actually tried soldering the flexi bit of one of these into a pipe before, but it is a tight fit, which is good. My tactic is to just put plenty of flux on and kind of pack it with solder to try and fill up these grooves. I'll obviously leak test the finished pipe afterwards just to check. So I've got the flexi bit going into this elbow facing down, so my thinking is that gravity will kind of help fill that up with solder. Like I said, I've never done this before, so let's see how it goes. It's not neat, but it will be. So next up, it's going to be the pipe from the outlet of this top radiator to the inlet of this one. So I think it's just going to be a couple of 90-degree bends, and hopefully that will line up nicely. And there it is, mocked up in place. It's starting to look pretty cool, isn't it? Okay, let's get soldering again. So that all fits perfectly. I had to take into account what I mentioned earlier about this radiator will be a couple of millimeters further out than it was, and it is now, so that's why it's at a slight angle, because this is pushing it out to where it will be, whereas the bottom is kind of just wedged in place underneath. But that'll be fixed properly during the final assembly. I love it. It's looking so cool. I'm really, really happy. This end in particular just looks crazy. Looks like an old boiler or something. There's one more pipe run to do, and that's where I'm going to leave it for today. So that's going to be the outlet of the monoblock to the inlet of the pump. The only remaining tubing run is going to be the outlet of this radiator to the inlet of the monoblock. But as I mentioned earlier, that's going to be a flexible hose. So I'm going to do a bit of research into which fittings I want at each end of that, since that's not going to be copper. So I think what we'll do is solder directly to the block, but so it's all removable and easy to work with now, I will just kind of place the fitting over there where we want to solder it, and then we'll deal with the direct soldering to the block again just before the final assembly. So I haven't really worked out what I'm doing here yet. Let's have a little play. So, things I'm trying to bear in mind while planning where this last pipe run will go are this cutout in the MDF. This is where 2 pipes and as much wiring as possible are going to come through. So I don't want a pipe to come up here and have any kind of straight section running along here, because that's going to block off a lot of the pipes. Sorry, a lot of the wiring, a lot of the space for the wiring. So I don't want anything like that. The other thing is I don't really want the pipe to come out here, because again that's going to have to take a bend here and a bend here to get to this port, because I need to leave space for the inlet port here, which is going to go over here. So I don't want anything kind of coming out and maybe covering bits of that, which is going to restrict what fittings I'm able to use here. That means that the pipe that I'm making has to come over here. And if it's doing that, that's much too close to the pump to kind of come down and just go in to the inlet port. So it's going to have to come down and do some kind of loop to come back into here, if that makes sense. So the general idea is something like that, with a 90 on there. Now the output of the monoblock is slightly too low, but obviously we can just solder in a different length pipe into there, so that's not a problem. So I think it's going to be like that, just with a straight pipe connecting here. So I'm going to mock that up and then show you how it looks. I think that's the one. Plenty of space for wiring up through the middle. Just clears that spine. It's going to be a tricky one to solder, but I think that's the one. Let's do it. And at long last, all the soldering is done. So all the copper pipes are finished. I've leak tested them all. They all hold 30 psi. And now I need to clean them up. So there's a few different stages I'll go through to clean them up. I've obviously done quite a messy job in places like this. There's a lot of big bulges of solder hanging out the side. So there's several stages to this. Firstly, if there's any really big blobs like this, sometimes to save a lot of time you can just grab them with some pliers and kind of crush off the bulk of it. After that, I use a Stanley knife, and I've got a carbide blade in here, and that just doesn't get blunt, so any kind of blobby bits that aren't big enough to grab with pliers, you can just shave them off. Then I use various small files to remove more material. Then I'll use some sandpaper, various grades, to remove the rest of it. I'll then just clean up any tiny little marks of solder on the linishing wheel. That's just a quick way to do that. And then I'll use polishing compound just to give them a nice shine. Here they are, guys. I've not quite gone for the final polish, because obviously these are going to still be handled for a couple of weeks while we finish the rest of the PC. So being copper, they're going to turn brown again. But I really wanted to see what they'd look like polished up, so I'm going to put the PC back together. That is definitely the most difficult plumbing job I've ever done. But it all fits. Oh, I'm so happy. So last time we did all the plumbing, we did the case welding, and we're just going to go straight back into the plumbing because there's one more pipe we haven't done yet. And in the last episode, the plan was to use some kind of flexible hose just to join this last bit, meaning that we could then bend it out the way to fill the loop, and it would just be an easy way to do that. However, I think I've figured out a way to do it all in copper and still be able to fill the loop. Now, if you've ever done a water-cooled build with hardline tubing and no reservoir, then you'll know how much of a pain this is going to be to fill. When you use a reservoir, you normally have it directly above the pump, which is here, so that as soon as the reservoir has enough water on, you can turn the pump on and just keep topping up the reservoir, and the pump will spread all the water through the system. We don't have that because the inlet of the pump is here. Copper tubes as well have a very large inner bore compared to a lot of water cooling tubes, so it's very easy for water to fall past air, leaving bubbles in the system. So I have a plan. If we imagine that this bit of pipe is connecting this last radiator to the inlet of the block, so this is the only remaining pipe run we need to do. Now, how do we get water into the system in this pipe reliably? And some people will say you can use a T-piece and just fill it up, pour water in. That's not going to work because the water will just fall down to the lowest point, and there's no way that you can push it one way or the other way, and it's not going to get to the pump to be able to, for the pump to have an uninterrupted water source to then push it around the system. You could use 2 T's because the issue is you need to get water in and air out. But again, this doesn't help anything because you can pour water in one, but there's no way to push that in a particular direction. So if we had water, if we poured water into one and sucked air out of the other one, all that's going to do is eventually just suck the water out through this path rather than it following around the whole loop. So what we need is some kind of way to block off the middle. That way we can have, you know, a hose in here, fill the hose up with water, block off the middle, suck air out of here, and then the water will be forced all the way around the loop rather than just taking this, which is the path of least resistance. So we can achieve that block with something like this. Now this is called an isolating valve. So we could plumb that in, and then you can turn this and it will block it off. So that's open, and then that's closed. So we could do that, but what I don't like about this is, one, it's quite big, quite chunky, quite ugly. You can only get them chrome plated. You can't get brass ones without the chrome plating on. It is made of brass, but it's plated in chrome, and that just doesn't suit the aesthetic of everything we've done so far. Also, the bore through the middle is quite small, and while the bore size isn't everything, I don't like the idea of putting kind of an unnecessary restriction here when all of the rest of the loop has a nice 13.5mm inner bore, which is the inside diameter of 15mm copper pipe. So you can get versions of these which are full bore versions, which have a bigger opening through the middle, which would negate that issue. However, they're even bigger, they're even uglier, and they're also only available in chrome. And other than that, I don't know what metals the insides are made of. I'd imagine it's stainless steel in there, but I don't know for certain, and I just want to make sure that the whole loop is copper and brass. Hey guys, Future Felix here. I'm just editing this and I realised I didn't explain this very well at all. There are a couple of other ways we could have filled the loop. One would be to use an off-the-shelf water cooling stop valve. We didn't like the idea of that because they only come in normal water cooling finishes, which are black and chrome, and variations on that. You can't get them in bare brass, so it's not going to work aesthetics-wise with what we've got. The other thing we could have done is a vacuum fill. A couple of you have mentioned this, so thank you very much for the idea for that. This needs to be a PC that can be serviced by the customer, and we don't want to give them something that they also need to buy a vacuum pump to be able to drain and fill the loop. So that's why we didn't bring those up. Okay, back to past Felix. So what we really need is something like this in the middle. And this, you can see, has a much bigger bore, and if I open it, it's got a huge bore the whole way through. That's not going to be restrictive at all. However, it's massive. And while there is technically space for it, there, I don't really like the idea of a giant tap in there. It would be a ridiculous way to do it. You also couldn't really access the tap to do that when it's in place. However, this tap doesn't need to be this big. Now it's got a compression fitting on each end, but the body of it is brass, which means we could solder to this if we want to. There's nothing stopping me chopping off these threads, soldering a pipe directly in there, but you've still got this giant top piece on. So let's take that apart and see how much of it we can lose. So that's that tap stripped down, and we can close it by turning this. And the nice thing about this case is that there's a hole in the bottom. So if we had some kind of tap here, you could access it from the bottom. So that's kind of my plan. Tap bit floating there, a T-piece here, another T-piece here, a bend into the block, and then this end will attach to this radiator. It's overshot the fixing, so we're probably going to have to loop in, back, round and underneath it to get it in there. And there's not a lot of space here, so I'm going to chop this down, take it apart, and then we can solder directly to it. So you can see the whole mechanism's come out. And this is entirely a cast brass piece, so there's nothing stopping us soldering directly to this. We're not going to damage any of the seals or anything through the heat of soldering because there's nothing else there. So let's chop this down and then try and mock out this last pipe. So there it is, I've chopped that down, and then I should be able to solder pipes directly into each end, like that. So here it is mocked up. We've got quite a few pieces to create this loop at the end to bring the body of the pipe up to the right height. We then have 1, 2 T-pieces either side of our brass piece. So let's give this a go. So those are all the parts laid out. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 18 different pieces. So yeah, 17 joins. I'm a bit nervous, but what can we do? Let's flux it up and get going. Okay, it's all laid out. It's jigged up. It looks to all be in a perfectly straight line. I'm really putting this off because I'm scared. Let's do it. I think I'm going to start with the brass piece in the middle because that's going to take a lot more, there's a lot more thermal mass there to warm up, so I'll do that first. Work this way and then work that way. I'm heating the brass from both sides because it's a much poorer conductor of heat compared to copper, so just to get the heat all the way through. And I'm touching the solder on it because when that leaves a mark, it's hot enough to melt the solder. There we go. shit. Oh shit. That's coming out. No. Go back in, go back in. So I'm watching this back and I clearly panicked at this point, and it really shows with what I was doing, because what I should have done is soldered this joint first, because the flux there is already black and burning off. So yeah, I'm very skeptical that all the joints from this point onwards have made a good seal, and that's why I'm making various skeptical noises throughout the rest of this. If that's airtight, that'd be a miracle. Right, leak testing time. I've put the rest of the tap back on just to seal that, and then I've got a plug for 2 of these 3 openings. Then the leak tester I'll put on here. Right, and then this end, I don't really have any way to seal that, so I'm just going to hold my thumb over it and hope that I can hold 30 psi. So with copper pipes, there's no O-rings or anything, so if it's going to leak, you're going to hear it pretty much straight away. So let's hope there's no hissing noises. Is that my thumb? It's losing pressure, but I don't hear a hiss. Oh, it really hurts. I'm going to try and get something rubbery to put in there just to hold my finger over a bit better, because I'm struggling to know if it's leaking or I'm just not pressing hard enough with my thumb. Right, that's the finger of a rubber glove, which is hopefully going to give a better seal. Let's try again. We're definitely losing pressure slowly. I don't think it's leaking. Yes, it's holding air. I realised my mistake. I realised why it was going down before, and that's because I had the tap section closed and I'm leak testing it from this end, and because the tap is not going to be fully airtight inside, the top is and the enclosure is, but inside it's not fully airtight. It's only made to handle water. I had it closed, and the gauge going down was me seeing the air going from this half into this half. So if I'd kept watching it, it would have eventually evened out as the pressure equalized across the whole thing. So now I've opened that, sealed the end, and it holds air. So that's amazing. I did not expect that to happen, honestly. The soldering did not go smoothly. But that doesn't matter, because it's airtight. So let's see if it fits. Okay, so I've got the telescopic version of the fitting on here, just so we've got a bit more wiggle room forward and back, just to make sure this aligns with the monoblock port. It fits. Just. That's so close. It is actually not touching though. Obviously this means we need to remove the riser cable to drain and fill the loop, but that's not really a problem at all. And it's not touching any of these contacts on the riser. They stop just before it reaches that plug. I mean, for safety I'll probably use a plastic plug, just in case there is any kind of flex in the pipe or the cable or anything, and they did short out. I'll use a plastic plug. But yeah, it fits. That's great. Let's check it fits in the case, because this is now the highest, furthest over point. And obviously the top edge of the case is curved, so let's see if it fits. Yes. Oh my God. Look at that. That's insanely tight. Something is stuck here. Ah, that's what's stuck. Do you see these little studs coming down from the top of the case? That one there is hitting this brass bit here, but that's not a problem. We can grind that off. They were only there for the original thing that attached the case to the inside, but we're going to have to be remaking that anyway. So yeah, we'll chop that off and it will fit. So I'm happy with that. I'll do that at a later stage. Now we need to do a couple of modifications to what used to be the tap. So I'll chop off the threaded section and then add a little slot so we can use a flathead screwdriver on this. There we go. So now that can be turned by a long flathead screwdriver from the bottom of the case. And then before we put this piece back in here, let's have a quick cleaning and sanding and polishing montage. Right, there it is. Nice and shiny. Let's put this piece back in. So everything's back together, and to recap, because I'm not sure if my ramblings earlier actually made a lot of sense, how we're going to fill the system is like this. We're going to have a flexible hose in here and a flexible hose in here. We're then going to insert a long flathead screwdriver up through the base of the PC to shut off this tap. We're then going to take this pipe, dunk that into a bottle of water or coolant, take this pipe and suck through it, and doing that will cause the water to shoot up this pipe, fill the entire system, all the components, and as I see it start to come out here, I will then put this pipe into the same bottle. I'll then turn the pump on. While that's happening, we'll probably pick up the PC, rotate it around a bit, just to move some bubbles around, and hopefully all the bubbles will come out through this pipe. Once the pump gets quiet, we're then going to insert the screwdriver again and open this tap. The system will be full of water and should be working. We'll then just blank off both of these with plugs, and then that should be a completely full PC. So I'm going to finish the plumbing now, and that means attaching the pipes to the block. And the original plan, or in my head, the plan was to solder these to the block so everything is, soldered and watertight. But looking at the order of operations, the order of assembly that will give us, that's going to be a massive pain in the arse, because this piece comes over here and goes into the pump. And if this is fixed in place, there's no space for the pump to go in and this bottom fitting to screw into the pump, because there's no movement in that at all. So that's going to mean attaching this to the pump and the block and having this whole thing that you need to mount onto the motherboard in one rigid piece. And I don't want to do that. It's going to be a massive pain to assemble if it's even possible. And if the customer ever needs to take anything apart, it's just going to make it an absolute nightmare for them. So we're going to use more of these. These are our extendable fittings. And the other thing is, the customer reached out to us and they said, that block that Steve at Gamers Nexus tested, that being our prototype here, this actually performed a couple of degrees better than this one did. This is the production run block. And the reason is the smaller fins inside the cold plate at the bottom. Now this was unmanufacturable at scale with the suppliers that we had at the time. They would throw away more than 50% of the manufacturing yield for these parts. So that's why we didn't go with those fins for the production run, even though they did perform better. But the customer said, hey, have you got that block? Can I have that one in my build? So we thought, yeah, why not? And then they'll actually be getting a part that's been touched by the tech Jesus, which is Stephen Burke at Gamers Nexus. So we're going to take this off, put this one on, mark on where the pipes need to go, cut these pipes down on here, and put a couple of these in. And as you can see, the reason these are so useful, we have an entire 20 millimeters of movement, which doesn't just account for poor measurements, which hopefully it won't need to. Hopefully my measuring's good enough. But what it means is the assembly is so much easier because you can put that on, have this out the way, bring this pipe in, and then bring it up and screw it into where it is. So it doesn't just give us a bit of leeway in the measurements, it just makes the assembly so much easier. So I'm going to take this off, put this one on, mark on where to cut the pipes, and solder some new fittings onto here. So let's do that. And you can see the differences between the two, the prototype and the production run. It's basically the in and out marks and a couple of fixing changes on the bottom. We got countersunk screws instead of dome head screws, but the positioning and everything is identical, so you can really see how close this was to the finished product. Right, so that is now bolted in place. The pipes still line up perfectly, so I'm just going to mark on here and then we'll kind of work backwards to allow space for the fitting. Bit of a patina there from the water, but still looks in very good condition inside. If anyone ever tells you that discoloration on copper does any harm at all, they are wrong. So we got our lines marked on here, and then our two telescopic fittings. So we have 20 millimeters of movement in these that we can use, and we probably want these to engage when they are most of the way out, just to keep them as out the way as possible during the rest of the assembly. So if that's where we want our pipe to attach, we then need to allow 2 or 3 millimeters for the solder in fitting on the other pipe, plus the size of this extended most of the way. Let's maybe push it back in slightly so there's a bit of size discrepancy. I think to make them equal, I'll line that up at the bottom, and that's 17 mil of the 20 mil. Then we need space for the solder and fitting on here. So from this line to this line. Okay, so it brings it exactly back to the block. Okay, I guess we're soldering these directly into the block then. We don't need any pipe. The only potential issue is this one's very close to the top. So is the thickness of this fitting going to fit in there without interfering with this when it's assembled? Because look how close that is. I think there's maybe a 1mm gap. And the pipes are 15 mil, the fittings are 17 mil, so theoretically that gives us a 1mm gap. I think the only way to know for sure is going to be to desolder these, put this in as a test, and then just check that goes back on. So I've clamped it between two pieces of aluminum just to stop any scratching on the block, and then I'm just going to heat here and just pull these out, hopefully. Hey! So that's now built back up, other than the bottom cold plate. And we can see just how close this is to this face here. So this needs to fit in here, and it just does. Now the edge of this fixing is actually lining up with the top of this block. The only thing that gives it space is the thickness of the gasket between here and here. And because of that, this screw head here actually would interfere with this. I don't know if you can see there. So if I try and push this fixing back in, it actually hits that screw head. Now that's not a problem, because we don't actually need all that adjustment. But it does mean that if this is soldered in maybe 2 mil too far out, it won't go in. It also means I'm probably going to have to put this fixing in before assembling the block. But yeah, it's soldering time. So we got these two little diameter reducers, and then we put one of these into each of these. And if my measurements are correct, we should see about half of this brass bit poking out the top of the hole. But just in case I can't get back in to fish it out again, I'm just going to flux everything first. So let's see if my measurements were correct. Yep. Yes, amazing. Now let's hope these don't do what the previous solder job did and start bubbling around. So there's a huge amount of thermal mass here, so I need to get the whole block up to soldering temperature. In case you're wondering why I'm heating the block rather than the actual fitting, I don't just want to burn off all the flux before the whole block's hot. Nice. I think that's clean enough for now. So I'm going to attach this to the top, but first I need to put the fixing in. So now let's assemble. Okay, and like just about everything with this build so far, it just fits. That should still give us enough movement. Cool. I do like these fittings. And then finally, I know I've said this like 3 times, it's time for the last bit of soldering, which is going to be to add these little fixings into the end of the 2 pipes that screw into the block. So one there and one in there. So I've said before that it's not really a good idea to solder half an elbow if you've already soldered the other half like we have here. But sometimes there is no other option, so we're just going to have to do it. And the best way is just to use as little heat as possible. But I'm also going to add another sort of layer of safety. I don't think we need to, but just for peace of mind, I'm going to do this. If you just wrap a piece of fabric around it, kind of near the join, you don't want it over half the elbow because you don't want to wick all the heat away. You just want to make sure that you don't kind of slowly heat up the whole rest of the pipe. So we're going to wrap that round and then wet it. So that's wet, and yeah, there's a good chance it will catch on fire, but that's not really going to do me any harm. So I'm going to heat as high up on this joint as I possibly can, just to stop as much heat as possible from flowing down the pipe. And this should work okay. This is really just kind of an extra layer of protection. I shouldn't really need this, but in case something goes wrong and I have to heat it for ages, this will just protect the rest of the pipe. So let's go. Cool, that went well. Awesome. So let's reattach everything and see if we have an airtight loop. Right, so it's leak testing time for the whole loop. Okay, it's not falling down straight away. Right, I'm going to go make a coffee while that hopefully doesn't move at all. I'm back. Has it moved? I feel like it was exactly that point before. I will have to see in the edit. Can confirm it has not moved at all. And it's now been tested for about half an hour. And it's still there, so that's great. So now that we've got an airtight loop, we can test fill the system just to kind of check that this weird tap mechanism works as we wanted it to. So I've locked off the tap here, so this is blocked off. I've got my inlet port running into this jar of water, and then this is the hose that I'm just going to breathe in through, and that should fill the whole system. Now, we haven't properly cleaned the inside of these pipes, or even the blocks, or the radiators, or anything, so I'm expecting the water to look a bit gross once it comes back out. But it's kind of a proof of concept just to check this works. I'm not going to turn the pump on yet, because I haven't done any of the wiring, so yeah, let's see if this works as I hoped it would. There we go, water's a bit greeny yellow. So when we properly fill this, we'll just run it through until all that gunk is flushed out, and then we'll turn the pump on. But it works as I hoped it would. And now I should just be able to blow back out through this and all the water will come back out. There'll be a bit left in the bottom of the radiators and stuff, so this level probably won't go all the way back up. But let's try that. Awesome. So that's the plumbing done. It's been a bit of a journey, but we've got there. So now we need to turn our attention to the case itself. And now there's three main parts of the case that we need to fabricate. That's going to be the front panel, the central spine down the middle on the inside, and the rear panel. So we're just going to do them one at a time. Front panel first. Now the original front panel consists of this black mesh piece and this aluminium piece, and that just sits over the top like that. Now this black mesh doesn't really look how I want it to. Black doesn't really go with what we've got here on the outside of the case at least. Now we could strip the paint off here and it would be nice and shiny, but it is made of steel, so it's then going to rust, which means we need to coat it in something. So what I'm thinking is the panel should have an opening here, and that's going to have an added benefit of either being able to suck air in or push air out. We're not sure whether the combination of these fans all moving this way are going to produce positive pressure or negative pressure, but either way, having a gap here or an opening here is going to help with airflow. So I'm going to mock up something out of cardboard and just see if that gives us the look that I was hoping for. Okay, let's see how this looks. The wonky central spine also really makes it look wonkier than it will be. So I'm kind of doing this knowing that it won't be wonky. So now I need to trace the exact shape of this onto this piece of aluminium. Then I'm going to cut it out, and then we will figure out how we're going to actually attach it to the case. And it fits so perfectly that it's completely wedged in place here. It's still got the film on this side, which is why it's white. Alright, let's make that cut out now. So this is one of those times where I have done exactly what I set out to do. I've done every individual part exactly as I hoped I would, and the end result looks awful. It's just really boring. I don't like it at all. We've got, like, functionally, we're going to get the advantage of having this hole, and the fans will either increase pressure inside and push air out, or suck air in. So for that, it's great, but it looks awful, and I'm really trying to ignore the wonky spine and the wonky pipe, which will be straightened up when we remake the spine inside. Even with that, it's just not right. It's too basic. Compared to the kind of retro 60s vibe of the outside of the case, it's just too plain, too modern maybe, and I hate it. So here's what I'm thinking. We take the original front panel, put it on top. Now that, I think, has the potential to look really cool. And because it's got these studs on the back, which is how it was originally attached to the case, they will act as a spacer, so we can have that over the top and still have the air, like any additional air will get sucked in or pushed out around here, and there's plenty of space. And the other advantage is the customer originally said that if possible, they want a power button and a USB port on the front of the case. Now we did say that that might not be possible, and it's sort of one of those things that we'll have to build everything else and then see if there's space for it. Currently, if we had something flat like this, there isn't really space for it, but having something spaced out by 6 or 7 mil, it looks like that's going to give us the additional space. I'll cut holes in here to have a USB port and a power button here, because it just brings it away from the radiator and the pipe, and it just allows us that bit of extra space that might make the difference to fitting a power button and a USB port in the front. So I think that is going to be my front panel. So I'm going to join those, I'm going to attach it to the front, and we're going to see how it looks. Nope. Okay, and that is our double layered front panel. It's in need of a polish. Let's see how it looks. Yeah, I think that's so much better. I think once we've got a power button and a USB port in the front, maybe in a contrasting colour, maybe brass or something. Could even have a little plaque down there. Little Billet Labs logo, power button, USB port. Something like that. Give me your ideas, guys. I'd love to hear what you think. Because you can stare at something for so long trying to be creative, and you can get a bit lost in just staring at it and stuck for new ideas. But I'm happy with this. I'm very happy with the front panel. We've got a nice air gap there. And yeah, it's coming along great. Now what you may have noticed is this MDF central spine has become a complete banana. It's so wonky. We've got about 1 centimetre of warp along the length of it. And that's just making doing everything else really difficult. So I'm going to tackle this next, because everything I've been doing, I've been kind of having to preempt the bend of the spine and when that will become straight and work around that. So we're just going to make it straight. A lot of people have suggested, why don't you make it out of sheet metal? Now the advantage we have with this piece of MDF is that it's 9mm thick, which allows for the thickness of these little threaded inserts. They take an M4 screw, and these are 6mm thick. And for these to go into the end of the piece of wood, that wood needs to be 8mm thick, because that allows for 1mm either side of this fitting, which fits an M4 screw. So why don't we swap this for a piece of aluminium sheet? Now if we're making this central spine out of sheet metal, what we need to do is add a bend to the bottom of it, because it's going to come down, and how do you attach it to this bottom piece? Yeah, you put a bend in the bottom so that you can drill holes in that little return tab, and then have a nut and bolt going through it, or a threaded hole, and just mount it to this bottom piece. So I've got an example bend in this piece of sheet here, and this would either have to go left under the motherboard or right under the radiators. And the issue is that both the radiator and the motherboard are completely flat against this bottom piece. So by having that return there, that is going to lift up either the motherboard or the radiators by the thickness of that material. And if we're imagining it's, let's say, 3mm thick, then the motherboard or the radiators are going to have to be raised up by 3mm to allow for that tab to go underneath it. There is no other space, so these are touching here. If we have a tab, it has to go underneath one of those components. And because, as you've seen in other episodes, the corner of this radiator more or less touches the edge of the case, as does the edge of the riser cable that is fixed in place in relation to where the motherboard is. So by bringing up the motherboard or the radiator by, let's say, 3mm. We're also going to need to bring it in by 3mm, and that is because the tops of the case are rounded over, and these points in the top corners touch the curve about in the middle. So it's at about a 45-degree angle. So by raising it up, you need to move it in by the same amount. So swapping this 9mm piece for a 3mm piece of aluminium will only save us 3mm rather than the 6 that you would think it is. So then the other thing to bear in mind is that this is the back plate of the monoblock that's behind the motherboard, and this is currently routed into this central spine by its own thickness, which is 3mm. So that's another 3mm that we will not gain by reducing the thickness of this spine. So what that means is swapping a 9mm piece of MDF to 3mm piece of aluminium will save no space at all. Which seems weird, but because of those two reasons, that is the case. So that gives us 3 options really. Option 1 is to make it from sheet metal, something like 3mm aluminium. We'll put a bend on the end and have some holes in that to attach it to the base. Option 2 is to go for a thicker piece of aluminium, something like 6mm plate, and that's thick enough to allow us to drill and tap threads into the sides of it. And then option 3 is a nice piece of hardwood, the same thickness as the MDF that we'll be replacing. And after thinking about this for a while, I think we're going to go with the hardwood. It won't be this colour. This is sapele, I think you say it. Sapele. It's a nice piece of wood. It's hard. There's no grain deformity. There's no knots in it or anything. But it's not a very nice colour in relation to the rest of the build. So I think we're going to go with this. This is 9mm thick, and then once it's done, we're going to stain it black, so it will look a lot less obviously kind of red, but you still get that kind of classy look of wood grain. So once again, we're going to strip the whole thing down, take this piece of MDF out, and then trace it onto here. And there it is. It's done its job well over the last couple of months, but yeah, there's definitely an upgrade. So throughout the build, we've cut various bits off of this piece of MDF, and it's obviously not looking particularly neat. On top of that, we've made some changes as we've been building the thing. One thing, for example, that we've noticed is that the little radiator that goes here is actually fully rock solid without any of these mounts on, just by the copper pipes that hold it from the 2 positions at the top. So we don't actually need any of these. So we can remove all of these bits here that overlap and block any of the flow from the fans. So we can get rid of all of that. Also, the 2 radiators are so rigid and held together that this little piece that ties the 2 end screws together, we don't need that either. All we really need is these 4 holes and these 2 holes for those 2 big radiators. So we're going to get rid of all of that. We'll keep this kind of curve around here, and we'll line everything up about there and about there. I'm just trying to even out these curves by eye a bit. Okay, so that's everything marked out. I've got all the holes marked, I've got all the lines marked, so I'm just going to jigsaw these, drill these, and then route out this area here. So we have our holes drilled, and I'm going to do the routing first because that's the thing I have the least experience doing, so that's where I'm most likely to screw up. And this board is 9mm thick, and these little threaded inserts are 8.5mm long, and since we're taking 3mm out to put the base in, I need to take 2.5mm off the length of each of these. with some hearing protection. Any tips anyone has on using a router would be very much appreciated. It's quite a new tool for me. Nice. So that is the hard part done. Next up, it's going to be drilling holes in the bottom piece of this to put in these little threaded fittings. Now I've done this enough times to know that however well you center punch it and however accurately your drill goes in, it just needs to hit a hard bit of grain and it will go off to the side. So I'm thinking I'm going to use my Dremel and a carbide burr just to kind of scoop out a lot of material just to center the drill better than a center punch will. Maybe unnecessary, but for me, I think this is what's going to work best. So that's the central spine done, for now at least. We haven't sanded it, we haven't deburred the edges, and we haven't stained it black yet, which we're going to do in the final build. But I'm really happy with how it's come out. We've got all the little threaded inserts. They're all glued in and they're all central along that 9mm dimension. And we have our back plate routed and set in there nicely. And I haven't snapped off any of these long spindly bits, so that's great. So we've got it all built back up again. We've got our nice bit of sapele on show there. So it's time to figure out the power button. So even though we've got this kind of double layer front panel, the back layer touches these pipes. And if you look where this gap lines up with the pipes, it's exactly in front of it, and it perfectly covers this entire area. So unfortunately there is no space at all for a USB port here, because there's just no space. There's nowhere it can go without having it up here. And I think the negative impact that will have on the aesthetics of the case is more of a bad thing than the USB port would be a good thing. So we're going to only deal with a power button here. That's all we're going to have. Now I've got the original power button that came with the case, and that originally attached here and here and kind of aligned with the front of the case so that when it slid up to this gap, it was just behind this, this opening here. But the distance that this button protrudes backwards into the case means it's just not possible to have it there. It just hits the pipe. So we're going to see if we can slim this down to maybe kind of reuse this piece and the button and see if we can make something work there. So I've taken off the standoffs, and then we still have a functioning button. Obviously it doesn't look particularly good, but we can do something to sort that. And it's much flatter, so let's see if that gives us a bit more space. It's still sticking out too far, I think. It's hard to know with this bit because the radiator's in the way. I think even if we do reuse this piece, it's not going to work with these holes in the front because we don't have a USB A or C, or I think that was probably a headphone or a microphone jack. We're not going to use any of those. We'd make something else to go over the top of it. So for trying to make this work, I'm just going to chop this off, leaving the only bit we need that could be attached by one side, because the radiators are in the way of here, so we can't use this bracket anyway. Right, I've been staring at it for 20 minutes now. Here's my plan. I think I'm going to try and get it here. Now that's going to mean that currently this diagonal piece here is interfering with the pipe, so I'm going to chop out a section of that so that it slides under the pipe, and then I'm going to use just a nut and bolt to fasten it to this bottom piece. So that is bolted in there, nice and solid. Nice positive click. However, obviously it looks terrible, so we need to kind of polish this turd. Now you can see there's space for this button to sit behind here, but it does go through this piece. So I need to cut out a hole here for the frame of that button, in the hope that when it pokes through into this visible area here, we've still got enough kind of thickness to do some nice kind of button. And I'm not really going to know what options we have for that until it's in place. That's our cutout done, and it fits quite nicely around there. So let's reattach the front piece and then see what we're working with once it's all together. So that is where the button sits with the front panel back on. It is actually just aligning with the inner edge of this front panel. So unfortunately that doesn't really give us a lot of space to put something nice in front of it without that nice thing protruding out the front of the case. So I think what I need to do is space this panel slightly further away, just by 1 or 2 millimeters, so that I can fit a piece of sheet metal in there, and then you will see my plan over the next couple of minutes. So that is our front panel done. We've got the button, works perfectly. And now it's time to do the back panel. So all I'm going to do here is trace this out onto a sheet of aluminium, mark out where all the holes are, and then work out where we want our power supply to sit and the cutout for the motherboard I/O. So the camera ran out of battery there, but that's cut out. I'm now going to drill the holes to mount it to the case, and then once it's mounted in place, then we'll kind of fine tune all the holes and stuff and decide where we want the power supply hole. So it seems to fit well enough. There's a lot more tweaking to do, of course, but the bolt holes line up and the outside profile lines up nicely. So now we're just going to spend probably an hour or two slowly filing out this gap because the motherboard I/O is stopping this panel sitting flush. But of course I don't want to enlarge the hole too much, so I'm just going to have to go really slowly. That's pretty much perfect. Really nice fit. Now this is currently just a straight cut through here. I think what I need to do is angle the back away, kind of angle it backwards, because the front of the motherboard has a bit of an angle on it. It's not a perpendicular edge, if that makes sense. That's looking pretty spot on. Right, now we need to do the cutouts for the GPU here and the holes in the cutout for the power supply here. No. I will be right back. I'm off to buy a new Dremel. And we have a nice shiny new Dremel. I did try and fix the old one. I took it to pieces and couldn't see anything wrong with it, so I just chucked it in the bin. Alright, let's see if this fits. So I'm going to mount the power supply first. This is the moment of truth. Yes, yes, come on. So I wasn't blown away with how that looked. So I did a bit of thinking. I was wondering what I don't like about it, and it was the black screws. So overnight I've ordered some brass fittings and reattached it, and I think it looks better. It also matches these little Wi-Fi antenna ports on the motherboard, which is quite nice. It's not perfect. It's still a bit two-dimensional. But we have a couple more features that we need to add. One of those is going to be a way to pull this out of the case, because the original back panel had this little handle here. So you can pull it out using that, and we don't have anything equivalent, so there's no real way to kind of grab this and pull it out. And the other thing we need to add is a way to fasten this into the case, because the original case had a little thumb screw that you undo, and we've got pipe work in the top, so we can't put that back in. There's not enough space, so we need to come up with another solution. So I'm thinking that that handle and the fastening mechanism might add a bit more interest to the back panel. So we're going to do those first and see how that ends up looking. So I'm going to focus on the fastening mechanism first. Now there's really kind of no space anywhere to fasten this panel to other than the front of this plastic dovetail down here. So my idea is to drill a couple of holes in here and then have a couple of screws in the back panel which fasten into those two holes. I could do one, but with it being plastic, I kind of just want to make it a bit over-engineered because of the weight of this thing. We don't want to be picking this case up, tilting it, and the whole PC falling out. That would be awful, catastrophic. So I'm going to take the case apart a bit more and see what we're working with under this plastic thing. So the idea is that we will put a screw through, or a couple of screws through, here and here, and have something threaded in here to receive the screws. Now there's so little depth here, I can't actually fit, this is an M4 screw, I can't actually fit a standard M4 nut in this depth, but these threaded inserts are smaller than a nut, so they just about fit. And here is my solution. I've cut two little bits of oak, and I've got these little threaded inserts. I'm going to glue them into here, and then that is going to give us a much bigger surface area to bond down to here. And we'll have a nice strong connection there, hopefully. So I've just keyed the surface with some sandpaper, because plastic sticks terribly to epoxy, especially when it's a bit shiny. I'm going to let them cure with these bolts in, just so they cure in the correct position. Now this stuff is workable for about 15 minutes and then takes a couple of hours to fully cure, so I will keep them fastened for 15 minutes, then remove them, because we don't want a tiny bit of epoxy to soak into one of the threads and glue these in. So the epoxy's cured, and these bolts will go in and out smoothly. It's not quite as easy as the original thumb screw on the case, but when you're building with a 4090 and a 14900K, you obviously have to have some compromises in this kind of case. So I'm happy with that. So the next thing we need to do is add some kind of handle to here, something we can grab onto and slide the case out. And what I'm thinking here is keeping it fairly basic. I've got this piece of aluminium bar, and I'm thinking if I just put some little pillars or some spacers, like some standoff type things, where these two bolt holes are, and screw through some holes in this bar, then we can just make basically like a little door handle type thing, and that will be enough to pull it out, but it's not, you know, big and bulky, it doesn't take up too much space. Now I'm looking around the studio for something that I can use for the little legs, the little standoffs for this handle. And I've just had the idea. I make these, through my other business, I make these spinning tops. And in my scrap bin, I've got a couple which were like wobbly. You can see that is not spinning as it should do. So I can use the shaft of these and just chop that off. And there's another one there, which is damaged for some other reason. And I think these little knurled bits, they have a hole through already. I think they will make a really nice little standoff. So I don't even need to buy any material. I can just use what I've already got. So let's quickly drill these out to 4mm. These are not the correct drill bits for brass, as you saw by that. And there's a little brass leg. There it is. What do you think? I like it. I'm not in love with it, but it's, you know, it's a rear I/O panel. I don't think anyone's in love with their rear I/O panel. I think it's good. And then to take the inside of the case out, you just unscrew these two. I know I hate slotted screws as much as you, but they're brass, so they look shiny. Then you grab this handle, and that's how it comes apart. I think I've realised why I don't like it. This is too blank. There needs to be something here. So yeah, if you've got any suggestions, what do you reckon? Like, I could put a logo there. We've got a load of these 4090 backplates. We made too many, so I could cut this out and put it on there. But then I think the copper is a bit too much with the brass and the alley all in the same place. I also found in my scrap bin this nice brass ring, so we could maybe have like a vent hole, but a circular kind of brutalist style one. Yeah, I think we'll come back to that. I'm gonna mull it over. But if you have any suggestions, please drop them in the comments. I've also been thinking about putting some legs on it. So as a hoarder of nice metal things, I actually have 4 of these little turned brass pieces. And I kind of want to use them as legs. It kind of looks like an oil rig. It kind of looks like the Barbican Centre. And I don't think either of those are a bad thing. But it doesn't look like a PC. Is that good or is that not good? I have realised what I don't like about this. I think the top and the bottom of this need to have a curve in them so that this screw is concentric to the curve at the end. So I'm going to do that and see if I like it more. That's better. Now the final thing I'm going to sort before we finish this episode is this wonky radiator, which you may have seen. And the reason it's wonky is because it can't sit where it wants to, because this pipe is interfering with the back edge of this fan here. So I need to take this fan off and grind the edge down. So I've taken off a bit of this edge and this whole corner as well, because that was touching one of the copper elbows. So let's see if that fits better than it did before. So that is now perfectly straight and parallel, but only while I'm holding it up. If I let go, it does sag down a bit. So I'm just going to make a little bracket to go here. So while I figure out exactly how to make that bracket, I luckily had this perfectly sized brass cube, which is just going to be holding up for now. The reason I'm not making the bracket now is there is also going to be a 2.5-inch hard drive that's going to be sitting under that radiator. So we might want to make that bracket one thing that holds the radiator and the hard drive. So we will get to that when we start installing the drive. Then the final thing we're going to do today is mount this pump a bit better, because the screws are just sitting in little filed channels in that piece of wood, and there's quite a weak part here. I've already snapped off a piece of wood there. So I'm just going to make a little bracket that sits over the top. We've got enough space to play with in the height of the case, because we can go up to here. And yeah, I'll just make a little plate with a couple of holes that will sit over the top and bolt that in a bit more firmly. I'm not going to worry about the resonance of it and the vibration causing noise because it's so solid. We don't really even need it mounted here because the pipes hold it completely in place. Like, I'm unable to pull it out of there. So the noise I don't think is going to be an issue because it's just going to go straight into the entire case, and it's so heavy that there's not really going to be any resonance there. We'll see anyway. If we turn it on and it is really loud, then we will go back and improve on that, but I don't think we need to. And rather than using any new material, I've realised that this section of this original back panel is exactly the width of this piece of wood. It's aluminium, so I'm going to chop that to size, use these two holes here, countersink them, put some threaded inserts in here, and then grind off the original anodizing on here, and that should look really nice. So just to save me taking the entire PC apart again, I'm going to drill these in situ, which is a terrible idea, and I would not do it if these were the customer's components, but because this is our test motherboard and test pump and everything, I'm going to take that risk. I mean, wood shavings won't really do any harm, but still, you don't want bits of wood in your PC. So do not do this at home. So I got this little bit of aluminium done, and then we have two brass screws that go in there, like that. And then this should just bolt into here. I like that a lot. And to remove the pump, you can either take the bracket off and then just lift it up, or you can unscrew these two here and move it out that way. Cool. So last time I put the case on these big fat brass legs, a bit too weird, I think, aesthetics wise. So I have raided my scrap bin for some slightly shorter brass pieces. I've got 4 of these, and that's going to look like this, which I think still has the same kind of funky 60s brutalist vibe, but it's a bit less, out there. It doesn't add quite so much height to the case, keeps the volume nice and small, and yeah, that's what we're going to go with. So I'm just bolting these in with these M5 screws and one of those grippy nuts on the other side. And what I've done here, because this leg covers up this screw hole, I've hopefully done this so that you can put that in first, then put that through, and then you can rotate that to access the screw. There we go. So when that's bolted in place, I can still turn this screw. There we go. So those are the feet done. And after we've polished these during the final assembly, we're going to make some little leather or cork or something, kind of pads on the bottom to cover these old screw holes that aren't really being used for anything, and just to make it a nice, softer thing to sit on your desk. Feet. Done. So next up, we want to put a logo on the back, or something here. We need a logo on the case and we need something here because this looks weird. And I have to say that one of the comments from Scott Hayton, you said cut out the Billet Labs logo here, and you are right, that's the best option we've got. However, the pump is directly behind it. And if there was a gap there, I agree, that would look really good and it would act as a vent. But with the pump there, It's going to be kind of cut down the middle because you're going to see the brass here and then the kind of black chrome or whatever that finish is on the bottom of the pump here. And I think that's going to kind of ruin that cool idea. So yeah, awesome idea, but I think I'm going to see how it looks instead, like cutting this out here as a circle and just bonding that on, because I think in this particular instance, seeing through that is not going to look as good as having that as like a consistent logo. So we don't cut anything out and we have that copper logo over the top and you'll see the aluminium through it. I'm going to see how it looks. I'm still slightly concerned it'll look a bit too busy with all the different materials visible on the back. But yeah, like I said, we've got a few of these back plates we can cut up, so we're not really losing anything other than time by giving it a go and seeing how it looks. That was not the best tool for the job. I've managed to get quite an even angle on there for doing it by hand. I'm really happy with that. Let's see how it looks. I don't think I like it. Damn it! I don't know, I'm not actually sure that that is better than nothing. I don't know, maybe we consider somewhere else for this logo. No, that looks stupid. What I've made is a really nice logo that doesn't look good anywhere on the thing I want to put it on. So maybe we save that for something else. Right, I'll have a think about that. So the final thing I'm not super happy with is this little cutout here. We haven't neatened up the edges and that will undoubtedly improve the look of it, but it's just a bit weak. We got two very long thin bits of only 1.5mm thick alley. The line isn't perfectly straight either, but I was planning to fix that anyway. But I'm wondering about cutting some kind of little surround to go around here. I've got some brass, in case you can't tell, I hate buying new material, so I've actually got these brass light switch plates. I buy lots of stuff at boot fairs and stuff. And if I kind of cut that out to run down the side of the motherboard, line up with the top and the bottom of the motherboard I/O, and then cut a bit out of that, it might neaten this up. Again, I'm going to spend an hour on something before knowing if it will look good, but I think it has some potential. So I've spent a bit of time playing around with this, and I think this has some potential to look good. The edges are obviously a bit rough, but the idea is to attach this to the alley plate and then file the edges down together so that we have a nice smooth kind of brass to aluminium transition there. I think we're going somewhere with this. I like it. I think we'll call that back panel done for now. I'm going to get on to mounting the drive. So we got this little Samsung 870 EVO 4TB drive, and we've left a nice bit of space for that to go under here. It doesn't quite fit, as with most things on this build, but it should still fit within the outer case, even though it overhangs this little lip here. So I'm going to cut away this little raised section here, just so it can sit flat on the bottom there, and then see what options we have for mounting it once it's sitting there. So remember, we also need to mount this corner of this radiator somehow, and there's a little screw that's accessible here because we cut away that bit of the fan, so we can access this screw hole directly. I think it's an M3. So I'm thinking I've got this little bit of aluminium plate, so I'm going to make a cut here, bend this bit up, and then that's going to act as the mount to the radiator, and then the rest of this will act as a mount to attach the drive to, and then it will all be bolted to the floor there. Right, how's that looking? Oh, perfect. I shouldn't sound so surprised. That fits perfectly as expected, as I made it to. And there we have it, one of the most fiddly but completely unimpressive things of the build so far. So through here we put these two countersunk screws, then the drive mounts to the top through 3 holes like that, and then this bit will sit here, and these 2 holes go through the case, the bottom of the case, and can then be bolted through from underneath using a couple of nuts. And then with everything back together, you can see our nice little bracket there. And there is one more screw that's a bit fiddly to get in, and that just goes through the back of this bracket into the radiator. And it's done. Well, let's check it fits in the case still. If it doesn't, I think I'm going to cry. Okay, mount SSD, done. Okay, I'm going to try another time to make a logo. So I've got the rest of my brass plate here, and I've got our logo, which I've printed out and cut out, and I'm just going to trace it on here, and then hopefully we'll have like a floating brass logo in front of the aluminium. That's the plan anyway. Except Sharpies are terrible on metal. What pens do people use to write on metal? Let me know, I want to get some. Oh, it just soaks straight through. I've done it twice because the 2 parts of the logo are too close to cut in place like that, so I'll take the L from here and the rest of the B from this side. Right, I'm not going to attach these yet because I want to polish everything first, but this is the one. What do you reckon? Logo. Done. I'm going to do the wiring now. I love wiring. So the first thing we're going to do, the first issue that we need to tackle is that the 24-pin motherboard connector does not fit into the socket on the motherboard because this big brass thing is in the way. That is the socket for the cable. And this is just a little bit too close. So what I've done is I've bought a low profile one, and you can see the difference between the two there. So that should solve our problem. So I just need to, one at a time, de-pin all of these and attach this instead. This comes with some little crimps, little pins inside, but I think we're just going to reuse the original ones because why not? So I have disconnected one already here, and that is just going to go into there, but because the pins are slightly longer on here than the pins that come with this, you can see if that is in the normal distance, we're going to have a bit too much metal poking out the back. This already has some poking out, but just to neaten that up, and because it's going to be so close to a conductive piece of brass, I'm going to cut 24 or 23 because this pin is empty. Small pieces of heat shrink, just slide one over each time and then put it through. Right, let's see if our fresh new cable fits. So that's in there. I think we're going to have to do a bend. Remember, it's okay to bend things once. If I'm bending these back and forth all the time, the metal's going to work, harden and snap. But this is fine. I had to take the back panel off to access the power supply. And I've started wiring other bits in as well. We've got the 12 volt high power cable down there. That's looping up through this bunch of wires down to here. And, you know, wiring isn't the most entertaining thing to watch, so I'm kind of just going to get on with this and update you at various points. Right, we're getting there. Got most of the major cables hooked up. Next thing I need to do is shorten this CPU power cable, because currently it is way too long. So I've just marked on here where I need to shorten it. So I'm going to chop this off, recrimp these, and then reattach them to this plug. So that's our shortened CPU cable, and then I'm going to separate all the wires, and I will explain why I'm doing that in a minute. So with the pump, we've got this quite ugly yellow, blue and black wire, so I want to just put some heat shrink over that just to cover it up. But we've got this fan connector on the end, and the heat shrink I have doesn't fit over that, and any bigger heat shrink I buy, it's then going to be too big that it won't shrink over the wires. So I'm going to need to disconnect this fan connector, and I've not done this before, but I'm fairly sure you can just poke something small in there and push the little connectors out. Before that, I'm going to take a photo of it, because even though it's only 3 wires, I don't want to forget which wire goes where. So I don't have the exact tool for the job, but a tiny little flathead screwdriver should do it. Hey, there we go. Cool. So blue, yellow, black, that way up. Okay, I'm just going to check that still plugs in. Seems good to me. Okay, then we have one nice black sleeved pump wire. So that is everything wired. It's a bit of a mess, there's lots of things poking out all over the place. And what I'm thinking here is I'm going to do something that I haven't seen done before. I'm going to take a bit of inspiration from the automotive industry, and I'm going to join all these wires together in one single wiring loom. So places like here, you've got the CPU power cable, you've got a fan splitter coming around here. They all join up with the 24-pin cable. Wherever there are multiple cables joining or running alongside each other, I'm going to join them all together, first with some cable ties, and then I'm going to wrap the entire thing in loom tape. I've not seen anyone do this before. I had a quick Google, I couldn't find anything. I'm sure someone has done it, but I think that is going to neaten up a lot of this wiring. And that is the reason that I separated all the individual wires, so where there is a bunch of them, we can have them in a round cross-section rather than them all running alongside each other, which is going to be much more difficult to bundle together. So yeah, first thing I'm going to do is cable tie anywhere where there are multiple wires running alongside each other. Then I'm going to take the entire loom off and then wrap it with loom tape. Okay, so I'm done, but I've noticed here, bundling all these together into a circle means they don't fit down between here without putting a lot of outward force on here, which isn't good because that's going to be pulling the block away from the CPU. So I'm going to cut this, split this into 2 smaller bundles, and they'll both be running sort of one on top of the other like that. And I've run out of normal size cable ties, so I'm using these ones which will hold your car together. They sound so much better though. These will all be removed, if I didn't make that clear. All the cable ties will be removed when I tape everything. Hence why it doesn't matter that I'm using giant cable ties. Okay, so that's everything cable tied together. And now I need to take the entire wiring loom out, so that's probably going to mean disconnecting a few of these pipes. And yeah, we'll see what this looks like laid out on the table. And that is a wiring loom. Looks quite daunting, but that is every single cable to make the PC work. The only things we haven't included in here are the pump wire, and while it would have been possible to cut here and put a removable connector on, pumps do fail and we want it to be serviceable by the customer, and they come with this hardwired on, so we didn't like the idea of making that something that had to be customized if they ever wanted to replace it. We also haven't included the signal cable from the hard drive to the motherboard because that didn't overlap any other cables, that's just its own thing, as is the on and off switch. And here I've got my loom tape. Now this is not the same as electrical tape. You don't ever want to do this with electrical tape because it gets warm and it leaves sticky residue all over everything. This stuff does not leave residue. It's like a fabric based thing. And it sticks to itself much more than anything else. So it is. This is the same stuff they use, as I mentioned, to wrap looms in cars. So they sit in a hot engine bay for decades, and it's still fine. So that's what I'm using. I'm just going to very slowly start with the smallest bits, work my way towards the bigger bits, and yeah, I've not done this before, but how hard can it be? And I'm just taking off the cable ties as I go. Obviously we haven't tested this loom yet, so if we do have a dodgy wire somewhere, I am very conscious of the fact I'm going to have to do this all again, but you know, that's just something we've got to deal with. So I've reached the end of the first uninterrupted section, so I'm just going to loop this over itself a few times. And then here for the first time we have two bits joining, so I'm just going to go from this small one and then start wrapping over the big one as well, and then I'll probably go back down here with the same piece. Like, you want to use as few individual sections of this as possible, just because it's going to naturally be stronger if it's one piece. And there we go. I'm quite happy with that. I mean, wires are never going to look beautiful, but I think that is as good as we could get it to look with the sort of build that we're doing. And here it is with the loom installed. It was quite tricky to manipulate everything into place, but it's now all nice and solidly held in there. Couple of things I've learnt from doing this for the first time, and if you're planning to do this, pay attention to the angle that the wires need to separate at, because there were some places like here where I'd wrapped it around and these wires wanted to go the same way, and it took quite a lot of force to bend them out the way. And the same thing where you've just got bends here, because I held these all in place and then just wrapped it up, but I wasn't really paying attention to this right angle bend. So there's a lot of strength in it when you have 20 or 30 wires in one bundle. So it did take a while to kind of slowly bend those into a right angle to get it in there. But I'm happy with that. It's looking good, I think. Wiring. Done. So the next thing now is to basically assemble the PC with the customer's parts. However, I am off to Italy for 2 weeks, so we're going to have to wait till I'm back. Yeah, see you in 2 weeks. I'm back in England with my cup of tea. Oh yeah. Right, let's put this PC together. So first thing we're going to do is, well, what we need to do is basically go through every single component one by one and finish them to the quality of the finished product. So we're going to start with the case. It's picked up a lot of scratches over the last few months. So I'm going to sand those out and then polish the whole thing. I've been thinking about what finish we want on here. And I don't think we want a full like mirror polished finish because it's going to be a fingerprint magnet and a scratch magnet, and it will very quickly not look that great anymore. So I'm thinking of doing like a brushed effect, kind of like a DeLorean. So yeah, I'll get all the marks out first and then we'll see how that looks.
Wear a mask.
Right, so there we have it. Got a nice brushed finish all over it. Nice and consistent. And it just means that if the customer ever wants to, we can just supply them a bit of Scotch-Brite and they can just refinish it like that. So onto the underneath and the feet. And then with the feet, we're going to be making some little laser cut pads to go on the bottom. And obviously the other side is not visible, so we just need to finish the edges. And brass, just like copper, oxidizes as soon as you touch it with your bare skin. So rather than wearing gloves, I'm just going to make sure to not touch the edge once it's finished. The screws go in there first. Oh no, I've lost a screw. Ah, balls. Found it. For now, that's good. That's the outer case done. So we're going to do the front and rear panels now, and that's just going to be more of the same, but I need to disassemble this. And while all the aluminium is going to be brushed, we're going to keep the copper bits polished, as in shiny polished, not brush polished.
Wear a mask.
Oh, that's better, isn't it? Shiny. I think these need a bit of smoothing down before polishing. Shiny. So I've got a little thing I need to figure out here. If you look at these copper pieces, they're obviously much bigger than the studs here, so they're kind of free to move around. And previously during the assembly, I've just like manually positioned them onto the edge. So the curve is concentric with the outer curve here. But as this is the final assembly, we want to attach them a bit more permanently than that. So I'm going to position them all. And then I think it doesn't need to be strong at all, because once it's bolted together, there's no force on any of these pieces. So I think I will just put a little blob of epoxy on the inside of each one, just touching the copper. And then once this is bolted to here, there's no way they can move anyway. And then I'm just going to use a toothpick to kind of push the epoxy out so it's touching the edge of each of these pieces. And that should do it. I'll just give that a few minutes to cure. Okay, and then let's pop this back together. Nice. And with the front on, oh, I need to clean that bit up a bit. I'll do that off camera, you already know what it looks like. It's looking good. I really like the finish. Polishing. Done. So with the outside of the case done, we now need to fully disassemble every single component here. All the pipes are going to need properly cleaning on the inside and repolishing on the outside. The block's going to need polishing. We need to swap all the parts out for our new parts. Oh shit. Didn't empty my radiator properly. Got a bit of water on the power button, but by the time we turn that on, that'll be very dry. So here is every single component that's going into our PC. We've got our old test motherboard over there, but we're swapping that for this Z790i here. We've got our drives, we've got our RAM, we've got our chip. We'll see how that lasts. We've got our plumbing over here, and then yeah, the many small custom bits, radiators, fans, all the parts of the case and the block, the pump, etc, etc. So one at a time, we're going to finish these pieces and add them to the build. And it probably makes sense to start with the base of the case, which is here. So we've drilled a lot of holes here, there's a lot of bare metal on show, so I'm just going to neaten this up with some sandpaper and then just spray paint black over any areas that are not black. I'm going to do the same for this piece, which is the mount for the SSD, just because we want it to just blend in with the background, because you'll be able to see this through the vents in the side of the case, and we want the focus to be the case, not other bits of aluminium inside it. So we're going to paint these two black. At the same time, this radiator has a few chips that it's picked up, so I'm just going to smooth those down and give them a little extra coat of paint as well. So I need to go buy some paint. So I have my matte black metal paint with primer. So I don't need to prime any of this. I've masked up the radiator where I don't want the paint to go. I've prepped the surfaces of everything, I've neatened up this, and yeah, anyone who feels bad for this carpet is going to feel even worse for this carpet, because I'm not even covering it. Hey, painting's gone well. Everything is looking nice and unobtrusive. So next up is this wooden spine, and the edges aren't very neat. There's a few burrs around here where it's been cut. So I'm going to sand over the edges and then stain this black as well. So I'm not doing this the way that it says to on the tin. This is one of those paint-on wood stains that you may use a brush for. But I've used a few of these in the past, and you get quite noticeable brush marks. So I'm just dabbing it on with a rag, and I'm just going to slowly build up the finish, because it doesn't make a thick, solid black layer, but with a few coats it will. I just don't want to end up with lines in it from the brush. And it's water-based, so it dries in about 5 or 10 minutes, this thin. So I'm just going to keep working my way through various coats, and hopefully it will look black at the end but still like wood. So this is after about 3 coats. This is definitely not the right stuff. I shouldn't have used this wood stain. I think what I needed was a wood dye, but I've committed and I've made it look good, I think. I'm not going to keep going. I quite like this kind of very dark brown rather than the black. It looks black most of the time, but you can still see the wood grain through it. Wood stain done. Then next up is going to be the monoblock backplate, which is going to sit in here. And even though this will be completely hidden and out of sight, I'm going to polish it because I don't really know why, but I'm going to do it anyway. There we go, nice and shiny. I think it's looking nice. And then next up is going to be this back panel. So I'm going to take this apart, finish both these pieces with the same brushed finish that's on the case, and then I'll do the same for this handle on the back and the little B logo. and then we're going to glue that to here. So I've got the logo laid out where I want it, and my plan is just to take one piece off at a time, glue it, put it back on, and that way I'll keep the position that it's in. Yes. Go well, please. Yes. Just realised I've actually not sanded down the edge of that B. So there's some saw marks on there. That's the kind of charm that you get with a hand-built computer. Now we're going to add this back on, but before I do that, I'm going to finish the screws as well, because they are a bit discoloured. I'll just show you the difference. So I've just run this right one on the polishing wheel. Maybe you can't see because of the sun, but it's just going to blend in more nicely with this. And obviously we will be aligning the heads of these screws because we're not savages. Then to put this on, it needs to be attached to the rest of the case, so let's do that. So I've just sanded the heads of these screws as well. And then these two little screws in the bottom, they used to be black, but again I've sanded off the black just so it matches a bit better. It's coming together, guys. And next up we are going to tackle the motherboard, and I'm not sure how big of a job this will be because on our Z690i, the test board, we had to chop off the top of the VRM heatsinks. So I've looked at this and it looks about the same size. It looks to have about the same size heatsink as on the 690. So it's probably going to be a similar job. Oh God. I missed the motherboard, luckily. So this is the 690 and that's the 790. So you can see here we have cut off the top of the heatsink. It only becomes an issue if the heat pipe, you see that silver pipe in there, that takes the heat from the heatsink. Oh sorry, that brings the heat to the heatsink. But that's well below, and the same on there, that's well below where the monoblock inlet and outlet pipes go. So we're just going to have to chop this probably 2 or 3 fins down just to clear that. And this is a very over-engineered motherboard, so that will cause no noticeable difference, or no harm. You might be able to notice the difference in the VRM temperatures by removing that part of the heatsink, but it's still more than sufficient to cool the VRMs. Now what I need to figure out is how to take this heatsink off. And it looks like it is one piece with that heat pipe, or at least I won't be able to remove it without removing the heat pipe. There's one screw here, there's one screw here, and from memory the other board was just 4 screws, but I can't remember if I had to take this enclosure off. But we'll find out. I can see the 4 screws which actually hold the heatsink in, so I'll do them first and then see where we're at. Okay, that is loose now, but that wobbling that directly wobbles this, so I think this whole thing needs to come off as well. Things are loose. Okay, what is going on here? There's some tiny little fan cables, which I'm very scared of. I think you can see them on either side there. With that, I'll try taking these off. Okay, that hasn't really helped. Okay, I can take off one of these fans. Okay, after a bit more investigation, I've discovered that this sucks. This is going to be so difficult because, okay, unlike on the previous motherboard that we modified, this heat pipe that comes around here is like properly bonded into a channel. And I've tried kind of applying pressure here to try and waggle it out, and the heat pipe bent before anything happened. Only a tiny bit, so it's not going to affect the functionality or anything. But what it does mean is I need to, this entire piece, which was here, I've taken the fan off this end, but this whole piece can't really be disassembled anymore without risking quite permanent damage to the board. So I'll take out this tiny little delicate socket. There we go. So I need to chop off here all the way along without damaging anything else. So I think I'll wrap this in a bag and masking tape over it maybe. Please do not judge the general quality of my work by this. The blade has wandered up, so I'm cutting through a fin rather than through the gaps. So I'm going to file this flat, then I can get the saw in at the lower angle, which should make this a lot easier. Nice! So that's what I've taken off, and that is what we've got left. I don't know why I undid that from the vise, because I need to file it flat now anyway. So I'm just taking off any sharp edges and putting a tiny little chamfer on each edge. And the plan is to paint this black, so I'm just going to smooth it down very slightly with some sandpaper, and then it should be good to paint. And that's what we've got. Okay, and that is done. You can see I've bent it because this heat pipe is just copper, it's so weak, but because there are 4 mounting points, the mounting of that to the board will straighten it out, so that shouldn't be a problem. And we need to put it all back together now, but before we do, a couple of the thermal pads have got some aluminium shavings on them just from cutting, and we definitely don't want those little shavings anywhere near the motherboard, so we're going to replace those. And we've got some Billet pads here. I'm just going to cut a couple of strips, and these should be easily as good as the pads that were on there before. Now these two screws are squashing the new thermal pads, so I'm going to do them slightly tight, then just give it a minute for the pad to kind of naturally squish, then I'll give them a final crank at the end. Right, and that's our motherboard done, ready for installation. Customized motherboard. Done. So before we attach our motherboard to our case, we just need to think in terms of order of operations, and attaching this motherboard here will cover up the screw holes to mount the radiators and fans. So before doing that, we need to mount the radiators and the fans. Okay, fans and radiators are in. There's a bit of movement on this end of the radiators, but that then gets held together by that little copper piece that joins these two. So that will kind of add a bit of rigidity. And now we can attach the motherboard. But before that, we should install our drives and our RAM. So let's see what we've got. We have a Crucial T700 4TB, 12,400 megabytes per second drive. And then for the second drive, we have a WD Black 4TB drive, only 7,300 megabytes per second, this one. 32 gigabytes of 7200 megahertz Corsair Vengeance DDR5 RAM. And it should be fairly simple to install the drives. They sit one on top of the other here with a heatsink in between, but I'm still just going to double check the instruction manual for the motherboard just to check I'm not doing anything wrong. And I'm glad I checked, because one of the slots for the drives is Gen 5 and the other is Gen 4, and this is Gen 4 and this is Gen 5, so we just need to make sure the right one goes in the right one. They're both in, they're looking nice and squished between those thermal pads. Lovely. Now we can attach this to the case. I'm not going to put the CPU in yet, because I want that to have as little time as possible out in the open. So when we're ready to mount the block, we can take this cover off, put the chip on, and just do that all in one go. And then our monoblock standoffs just screw onto here, but we need some washers first over each of these studs. Now we're going to mount the SSD, so that just bolts onto here. So we put these screws into here, then this sits on here, and then that goes through there. Lovely. It's looking nice and subtle and black so far. I think while we're over here, we can add the power button. So the next thing we need to do is add this aftermarket contact frame, which is going to replace the original Intel mount there. these are proven to be much better, and especially on our monoblock, which has a flat cold plate. These make a massive difference. With our own testing against an EK water block, maybe a year or so ago, we beat EK by 3 degrees, and then in Gamers Nexus's testing, we lost to Alpha Cool by something like 20 degrees, and that is because the original mounting hardware applies all the pressure here and here, which basically folds the chip in like that, in kind of like a V shape. So all the pressure from a flat cold plate is then applied to the corners, and we're not cooling the middle properly. Whereas this applies pressure all the way around, it makes it very flat, and it's just going to give us much, much better temperatures. So we need to take this off and put this on. And I need to make sure it goes on the correct way round, which is that way. There's a little arrow in this corner, which is mirrored on this little arrow here. You might not be able to see because of the reflection, but it's that way round. And it should just be as simple as unscrewing this. There's a lot of spring tension in it, so I'm going to go slowly. I should probably take that off, to be honest, so it's not under tension all the time. There we go. And I should probably put the CPU in now as well, because this little safety cover thing won't fit with this contact frame, so it's probably safer having the chip in there, even though it's going to be exposed. And there it is, currently the world's most unreliable chip. But the customer is aware of all the issues with the 14900K, and they want it anyway. So we are now at the point of installing the block. Now, because we've had some water running through here, I just want to take it apart and see what it looks like inside. I'm only going to take the bottom off. If this looks fine, then the rest will be fine as well. And we're going to be flushing some distilled water through it for a while to clean out anything that is in there, but hopefully there's nothing in there. Yeah, that's fine. So we need to make the block look nice now. So there's going to be a lot of polishing on here, but before that, I'm just going to resurface this because it's picked up a few little scratches and some patination. So I've got some 2500 grit sandpaper, and I'm just going to work around in circles and just clean off the top layer. We finished this properly before, so there shouldn't be any deep scratches or anything that won't come out with this. That looks good, then just a quick polish. And this is now annoyingly where I need to start wearing gloves for everything, because we don't want my big ugly fingerprints when we give this to the customer. Shiny. So we're going to clean up these fittings, and to do that I have this, which is an ultrasonic cleaner, and that should just get all the gunk out the inside. We've had some just tap water running through here, so while they're not too bad, they are not super clean inside. Might be a bit of lime scale. So this should just remove anything that's stuck to the surface of the brass. Then we will assemble these fittings and get the block mounted. So I'm going to fill this up with distilled water. So that's on now, and if I lower this in, there's not like clouds of stuff coming off it, which is good thing. It means it wasn't super dirty to start with. These ones I think will have a bit more dirt in them. There you go, you can see it coming off there. Yeah, look at that. Oh, this thing is so cool. Just leave that to run for a bit. So we've had those in there for 3 minutes. Oh, they look perfect. Yep, super clean. That's quite impressive. It's the first time I've used this. It works great. Yeah, the water's definitely a bit cloudy and green now. So now we're just going to rebuild these fixings before attaching them to the block. And we've got this silicone lubricant spray, which is what we apply to the O-rings on the inside. You may have noticed, people who know about silicone, that we have silicone O-rings on the outside, and silicone lube dissolves silicone O-rings. But on the inside we have nitrile O-rings for this exact reason. So we can lubricate these two, and then we don't need any lubricating spray on the external O-rings. So I just spray this through here, like that. It's got a nice layer on the inside now. There we go. And once this little groove clears those two internal O-rings, it's beautifully smooth. And then they just get held on using these little stainless clips. There we go. Now that's an assembled fitting. Give it a little waggle around just to spread the lube around. Then we just need to clean out the grooves that the external silicone O-rings sit in, so that we don't have silicone on silicone. And then, there we go. Then we are going to attach these back to the block. Awesome. Now we need to mount the block to the CPU. And I've got my Thermal Grizzly Cryonaut paste. And we're going to go for the blob method. And then we just lower this down, trying to keep it flat so the paste spreads evenly. I'm just checking all the standoffs are the same distance from the top of the block, because that just means it's sitting flat, which it is. So then we just bolt it in place. And then I'm just going to keep pressure in the middle while I tighten everything. And it's mounted. So what's next? I think the pump next. And here is our pump top. We've got quite a bit of limescale, and it's gone a bit green in there. That's not verdigris like you get on copper. I think that's just limescale from the hard water mixed with a bit of the patina from the brass. But hopefully this will all come off in the cleaner. Let's give it a go. Yeah, it's definitely got all the little chunky bits off. I'm just going to give it a quick scrub with a toothbrush, just to loosen anything kind of physical, and then we'll pop it back in. So that's had about 5 minutes in total. Looks perfect to me. Remember, the discoloration is not going to be cleaned off, and it doesn't do any harm whatsoever. Feels perfectly smooth still. Cool, I'm going to go dry this off and then we'll give it a final polish. And we want the wire to go the same direction as the pipes when it's installed, so we want it to go this way round. So to install our pump, you've got these two screws that go in here, and that just sits in those little grooves. Then this just bolts in here. I'm just going to give this a quick finish on the polishing wheel along with the screws. So that's what it looks like before and after. And can we align the screws? Hell yeah, we can. So the next thing to go into the case is going to be the wiring and the plumbing, because they kind of need to be installed at the same time, because some pipes need to go on top of the wires and some of the wires need to go on top of the pipes. But before we start doing that, obviously these look a bit of a mess now, so we need to take off all the fittings, clean those, and then clean the pipes and polish the pipes. So they're looking pretty messy. I'm just going to strip these down, take the O-rings off, and then we will put them in the ultrasonic cleaner. So these are all stripped down. And yeah, the tap water here really isn't good. You can see the amount of limescale that's on there. Note to self, do not use tap water to fill a system and then leave it to dry for 2 months. Right, let's just put them all in at once. I haven't disassembled the fittings. I don't think I'll need to. We can lubricate them while they're assembled. So if all goes well, there should be a big cloud of dust that comes off these. So that was 3 minutes and it looks like quite a lot of gunk has come off. I'm going to just clean up the surfaces on the polishing wheel, and then I'm going to put them back in just to clean off any dust from the polishing. So now we're just going to lube these up. Super smooth. These are going to be marginally more difficult. I'm just going to cover them, then we'll clean any excess off afterwards. It should seep through the gap. Alright, they're all nice and smooth now. So I'm going to clean them up, add the O-rings. You don't need to watch me do that. So the next thing you're going to see is cleaning the pipes. And even though I polished these all before, I have done a couple of tweaks off camera. A couple of the angles just needed a fraction of a millimeter twisting round in some of the joins. So the solder is no longer neat in certain places. So I'm just going to re-sand all the solder off, and then I'll run it on the polishing wheel and then give it a hand polish. I love sanding. So everything is back to a nice pink copper colour, and I just need to make them shiny now. So everything is polished. We need to clean these now, and I'm aware that's going to get water on the surface which might discolour it again, but we've done the bulk of the polishing. We've smoothed it all down with the polishing compound. So if we do need to polish off any water spots, then that's going to be a much easier job. But I wanted to do the cleaning after the polishing because there's going to be polishing compound in all these gaps and stuff, so this should get that out nicely. Hopefully this will look quite cool. There's a lot coming out of here, isn't there? Wow. Well, that looks disgusting. I'm going to empty this out, put some fresh water in, and do it again with these same parts until the water stays clear. I think one more flush. Yeah, that's looking clean now. Then we need to do the same for the bigger pipes, but they're not going to fit in here. So I think we're just going to have to kind of lower them in half at a time. Pretty good. So that is all the pipes clean. We were unable to get the long sections of this one properly submerged into the cleaner, but they will be cleaned well enough when we flush everything through with distilled water just before filling it with the coolant. So this is everything that's left to go in the build, and it's just going to be a case of now attaching these all to here. So I'm going to do that. So it was all going well until I tried to attach this little joiner piece to these two radiators here. And it's too short. And this fit before, so I think what I've done is I have put the radiators the opposite way up to how they were on the test build. And there's a bit of variation in where they put their ports, and the result is that this needs to be 1mm longer. Now I could undo everything, swap the radiators over, and that should solve the problem. However, I think I'm actually just going to heat this up and desolder it slightly and just stretch it by 1mm. So I think I can do that in about 10 minutes, whereas redoing everything will take about half an hour. And my technique here is to get some parts of some other fittings, screw them in like that. Then I'm going to heat up here and waggle these apart. And I'm going to wrap some wet fabric around here, partly to stop it getting immediately too hot for me to hold, and partly to protect these solder joints. I do not recommend doing this at home. This is not best practice, but I've done it before and I think it will work. So I think we've gained a millimetre there. Just don't want to have add any twist to it, which I think we have. So yeah, we have twisted this. This leg is now up a bit further, so I'm going to reheat it and then just flatten it with a block of wood. So obviously we need to check it's still airtight. Yep. So it's back on. We're making good progress. We've got most of the pipes on. This one will just squish all this stuff. We've got our power supply with everything plugged into there. So the last bit of the plumbing is going on with the radiator attached, and we need to plug this fan connector in. And this is why the wiring loom is so good, because the fan connector is just sitting there ready. So I think we should have an airtight loop now. I'm just going to test that. Right, I'm going to leave that for about 5 minutes. So we're currently at exactly 12.5 psi. Let's see what happens. Right, where are we at? Hasn't moved at all. Yes! So all we got left to do now is the graphics card. So the customer supplied this 4090, and my understanding is they've used it for a little bit in another build. So let's see if I can remember how to take one of these apart. There's a little latch here. Cool. So now I think it should be free. It's just kind of stuck down with thermal paste and thermal pads. So I just need to very carefully pry it away. Oh, there we go. It's a little bit scary. There is our 4090. Disassemble 4090. Done. I'm just going to reassemble this as best I can without the PCB in, just so we can give that back to the customer since it is all theirs. And there is a complete 4090 with nothing inside it. So we can keep that safe. And now we're going to install the 4090 onto the block. So we need to take off these old thermal pads first. Then I'm just going to clean the VRAM with some isopropyl alcohol. I've already done that for the chip in the middle. And now this is our set of thermal pads that we supply with the monoblock. So we just need to, one at a time, place them onto the card. And that is it for the front. So now we're going to go over to the block, and first we're going to insert our 4 alignment tools, and we're going to place these 4 thicker washers over that. Then we need to thermal paste the GPU die, and then in one fluid movement I need to lower this onto the pins without any of the thermal pads falling off, which is usually not too difficult the first time. Just going to push them down a little bit. It's when you reuse the pads then they kind of lose their stickiness, and then this can be a bit of a pain, but let's go. Nice. Okay, then it's the rear thermal pads. Then we've got our 4 remaining washers. And they should kind of tuck inside these little plastic bits that are already on the PCB. Oh yeah. Then one at a time, just to not dislodge anything, we are going to remove the alignment tool and replace it with the screw. And it's in, and this should tighten to a fairly hard stop. But we are squishing 2 layers of thermal pads as we do this, so I'm not going to go too fast. I'm going to tighten a little bit, let the pads kind of spread out, and then tighten a bit more. So we're all set to fill our loop. We've got our PC, obviously, we have our in pipe, we have our out pipe. We've got this car battery, which I just took out my car. And the reason for that is that we need to turn the pump on separately to bleed the loop before we turn on the whole PC. So we've got the pump wire coming out the back here, which is then wired up. I've got the 12 volt positive input connected to the positive terminal on the car battery. And then when I join the negative terminal to the negative side of the car battery, that will turn the pump on independently of the whole PC. We've got a load of distilled water here. That's what's in this jar here. We've got a spare jug just in case things go wrong. And then we have our Corsair Hydro X clear coolant for once it's flushed. But we're going to be flushing it for a while with distilled water. Just because as well as we cleaned it, there's still going to be some kind of stuff in the loop which we don't want in there. So I've got this tap section here, which you may remember from one of the previous episodes. That is in its closed position, so there's no way for water to get from here to here. That means by me breathing in through this tube, that's going to suck water up this pipe, that's going to fill the loop, and most importantly the pump. And then once it starts coming out here, we're going to turn the pump on and then put this in here, and then that's just going to be flushing everything through with distilled water. And we'll probably do that until this gets dirty, and then do it a few more times. But let's do it. So there should be water in the pump now. The pipes are cold, they feel like there's water in there. There's obviously a lot of pipes and radiators and stuff, so it's not going to flow super smoothly through, but now there is no air coming out of here. So we should be able to submerge that and activate the pump. Going a bit slow, but there's going to be a lot of bubbles in there for it to be pushing through. There we go, it's picking up speed now. It's getting quieter. The noise you'll hear from the pump is water with lots of small air bubbles in, so when it goes quiet that means it's just pure water in there. It's working. Let's just check the pressure. Yeah, see, there's a lot of pressure there. Exciting. This part of it worked at least. I can hear a lot of gurgling coming from the radiators, which is a good thing. And you can see here the water going in is nice and clean. The water coming out has lots of little bubbles. So all those bubbles are bits of air we don't want in there. So just to speed things along, I'm going to rotate the PC around a bit and just get some of those air bubbles that are sitting like in the top of the radiator. That'll just get some of them into the pipes, which will bring a lot more of the air out. But because I don't want water to go everywhere, I'm just going to tape these onto here. I'll just hold them safely. So as I do this, probably a lot more air will suddenly come out of here. Oh, it's heavy. Yeah, there's a lot more coming out. And the water is honestly looking pretty clean. There's some bits in it, definitely. And that's why we're doing this. But it's not discoloured at all. I think all that ultrasonic cleaning definitely helped to speed up this process. And no leaks still. So I'm going to go have a cup of tea for 20 minutes and just let this continue to do its thing. So that's been about 20 minutes. The bubbles seem to have stopped. So before we swap the water and do it all again, I'm just going to turn the pump off and then on a couple of times. Just because that water flow stopping and then starting again can free some more bubbles. And then I'm going to empty this water out and fill it up and go again. This is really a job that you want 2 people for. Get these right back under there. And then we're going to put the pump back on. And we'll give it another little wobble. Yeah, we're getting some more bubbles coming out there. So with it on its end like this, all the air is going to be pushed to this end, which is all going to then be filling up this end of the radiators. So I think when I put it back down, we're going to see another big stream of air bubbles come out. Yeah, there you go, look at that. And then we'll go that end. But it's getting to the point now that whichever way we turn it, the pump doesn't make any noise. And that's what we want. And on the inside of the pipes, there might be various tiny little bubbles just sticking to the surface. So I'm just going to tap the pipes, which might release some of those bubbles, if there are any. So that's been another 10 or 15 minutes, and everything's running quietly. So I think we're ready to fill it with coolant. So I'm going to disconnect the pump. Again, this is going to be quite tricky with only one of me. So now the plan is to swap all the distilled water that's in here for coolant without letting any air in. So we could drain all the water out, then do all this again with coolant. But this coolant is 89% distilled water. So if we have a bit of distilled water left over, it's not going to be a problem at all. I'm going to fill this up with coolant. Then I'm going to turn the pump on, and the coolant is going to displace the water. The water will end up in there, as will a bit of the coolant. And then we'll put the exit pipe back in here once the coolant starts coming out. And we only want the inlet pipe in the coolant for now. And what I should have done is marked on this jar how much fills up the system. So I think I'm going to waste a bit of coolant by doing it this way. But I'm now going to connect the battery again. That's going to pump the coolant in, replace the water, and then once most of this has gone through, I'm going to turn it off and then refill it from the coolant, if that makes sense. I actually did it by the smell. Once I could smell the coolant in here, Then there's coolant coming out. Then this goes back in here, and we can then turn the pump back on, and then we have only coolant going through. Nice. And again, we'll just let that run for a few minutes. Pressure's still good. So I haven't seen a bubble come out in another 5 minutes. So now it's going to be maybe the trickiest part. I now need to open up this tap again, ideally while it's running, with these two pipes connected. This needs to be on its back. I really should have got longer hoses here. Hopefully this will work. So can I get this screwdriver back through? Yes. So I'm going to start opening the tap now. So that tap is now fully open, which means the pump doesn't need any of the water to be coming through from these two, and it's kind of just running by itself now. So I need to swap these two fittings for these plugs, but they're obviously still full of water, so I'm just going to give it a minute because we've got a few more bubbles coming out. Just the area around the tap, there was probably some air in there, but you can see the bubbles are now just sitting here. They're not being forced through because the water is coming from the PC rather than through this jar. Okay, I think we're good. So I'm going to turn the pump off, and I want to make these two fittings the highest points so that water doesn't pour out of them when I take the fittings off. And I'm just going to drain the water out of these hoses. Oh, that was easy. And yeah, we've probably got a bit of air in here, but there's always going to be a bit of air in there when we don't have a reservoir in the system. And that's not a problem. It might actually help us because when water heats up, it expands. So having some air in there, which can be compressed by the expanding water, is better than having it fully topped off with water. And then there's a slight risk of, if it's full of water and then it gets hot, that it might expand and pop one of the joins. But people seem to think this is a big risk, but there's no record of it ever happening to anyone. So because these are going to be wet when I open them up, I'm just going to pad everywhere I can with tissue just to catch any water, especially since it's right next to our 4090. So then we're just going to unscrew these. There's a bit of water coming out, but it is topped up right to the top, which is good. And then I'm just going to turn the pump back on and just check everything sounds all right. Yeah, bit of a noise from the pump because the place where the air is going to have come in goes fairly quickly to the pump. But all that air should eventually settle in the radiator, where there's a lot more space for it to kind of settle without getting agitated and churned up into foam and then sent back around the system. It's done. All we need to do is turn it on now. It's actually not quite done. I haven't done the pads for the feet. So we've got some nice little cork bases, and then on here we've left a gap where you need to access the screw to take the bottom panel off. And now it is done. So we've already spent about a day just installing every possible update, all the firmware for all the components, and everything is running flawlessly. It's working really, really nicely. It's idling at a really good temperature. So let me just show you that first. So over here we've got the fan curves that we're currently running. We've got the fans based on the CPU or the GPU temperature, whichever is highest, and as you can see we've got quite an aggressive fan curve here. This is kind of just to give the PC the best chance of performing well, but we're not going to spend ages tweaking these to keep it quiet, because the customer has said that they're quite looking forward to having a play around with the fan curves. They're like us, they're a bit nerdy and they like tweaking that kind of thing themselves, so we're going to give them that enjoyment, you might say, of playing around with the fan curves and stuff. We've got this basically here just to, this is effectively, the fans are on full almost all of the time when anything is doing anything. So over here we've got the temperatures. This is at idle. The room temperature is 21.3 degrees. So fairly average room temperature. And idle temperatures, the CPU is at 32. You can see every individual core there. Nice consistent temperature across the board. We have our VRMs at 44. And then the GPU is idling at 31.3. And that's with the fans really quiet. You can see on the fan curve, we're over here, this is the current temperature, and the CPU is hotter, so that is controlling the fan curve right now. And then I can also show you the monitoring software for both of the M.2 drives. So the primary drive is sitting at 59 degrees C, and the secondary drive is sitting at 60 degrees C. And bear in mind, we are screen recording right now, so they're having data written to them right now. As I'm doing this, I can't really show you what they look like without the screen recording, but they were sitting at 49 and 50 degrees. So I think it's time now to start stress testing it. And before I start this, I should say that if it thermal throttles, we're not considering that a failure. We have been asked to fit these components in this case, and I believe that we have done the best possible job and got the best possible cooling that it's physically possible to fit in this size of case, or in this specific case. So if it thermal throttles, that's okay. That was always going to happen. We're limited by the size. There's no way around that. We're hoping it doesn't thermal throttle. We've had similar components running with similar amounts of cooling and they didn't thermal throttle. But I hope that the CPU will be kept under 100 degrees, which is the thermal throttle limit, and I hope that the GPU will stay under 83 degrees, which is the thermal throttle limit. And if we can achieve that, I think that's going to be a big win for us. I will be really happy if they don't thermal throttle. I'll be amazed if they both don't thermal throttle when running on full at the same time, but that's an unrealistic test because nothing is really ever going to do that. The customer's going to be using it for like photo and video editing and gaming. So it's either going to be CPU or GPU. It's never really going to be running both on full at the same time. So with that being said, let's do it. So we're going to fire up Cinebench and we're going to do a multi-core test. So let's start that. CPU temperature is up here and we're now well within this temperature range. So the fans are basically going to be on full all the time now. And the CPU is at 68. It's really pushing some heat out. Okay, so it's not instantly thermal throttled, so that is awesome. Now it's not a massive loop, so I don't think it's going to take too long for the water to get up to its equilibrium temperature. But I'm still going to run a few CPU multi-core loads back to back just to check that we do peak at a temperature, and this is a proper test. So still we're in the 60s and 70s and the occasional low 80 degrees on the CPU. Oh, that's so good. Honestly, I was expecting it to kind of sit at about 90. Got a few 85s, 86s creeping in now. Yeah, it's really managing the heat surprisingly well. Oh, I should look at the wattage this is pulling. There we go, that's a fairly constant 253 watts. I didn't mention we installed the latest BIOS, which should have all the microcode updates for the Intel chip. So theoretically we're running completely safely here, which was quite good timing that was released before we handed this over to the customer. So they and us have a bit of peace of mind now that this should last. We don't have to strip it all apart and replace the CPU. So we're 8 minutes into this multi-core benchmark and the CPU temperatures are just flat at 72. I haven't seen this value go above 72. There's so much heat coming out of here. It's coming out all around here. Out here, I can feel it everywhere. There's a breeze even out here. So our design is definitely working well. So yeah, it seems like it's not going to go above 72. But just to be sure, I'm going to do like 2 more back-to-back tests. And if this sticks at around the same temperature, then yeah, I think we've proven that this beast of a toaster easily handles the 253 watts of the 14900K. Okay, so we're coming to the end of the 3rd multi-core test here. We've got a couple of minutes left, and this has just been sitting dead on 72, occasionally goes to 71, occasionally goes to 73. And the individual cores, it looks like they've peaked at 88 on core 5, but nothing has come close to thermal throttling. If we look at thermal throttling, it's all nose, so that's great news. Distance to thermal throttling, nothing has come within 12 degrees of that. So that's awesome. Well done, the toaster. Oh, and bear in mind, I've been downloading a game and screen recording in the background, so really well done to the little toaster. It's doing a great job. And while this has been going on, let's look at the other temperatures. The wattage has been very consistent, 253. The VRM is currently at 74. Peaked at 74, average of 71, so that's all perfectly fine. The GPU has just been idling at about 15 watts, and yeah, very comfortable. 36 degrees maximum temperature, sitting around 35. So I'm just going to let this Cinebench test finish, just in case anything changes, and then it is GPU testing time. So everything has finished, and it's very quickly come back down to 30 to 40 degrees across all the cores. I don't quite understand why this is saying 89, because that should show the maximum of this value, and that never got above 73. So I'm probably missing something there. But yeah, we can look at all the maximum values of each core. Core 5 peaked at 89. The VRMs peaked at 74. And yeah, everything's looking really good. For the size of the PC we got, that's an amazing result, so really happy with that. Alright, so everything has cooled down, and I've got Firmark open here, and I'm going to run a GPU stress test. So hopefully this doesn't thermal throttle, but with 440 watts, which is what this seems to run at, rather than the 250 watts of the CPU, we'll see how this goes. So we're idling at 32 degrees over here, and let's go. Okay, we definitely didn't instantly throttle. We're up to 51 degrees, 52, 51. It's doing very well so far, I've got to say. So we're drawing about 415 watts fairly consistently, and we're at 53 degrees. Hotspot is about 10 degrees above that, but we're nowhere near the 83 limit. We're creeping into the mid-50s now, which is still really, really good. And I also didn't mention, we haven't done any sort of undervolting of anything. Everything's just running with the latest updates, the latest firmware and everything, but we've done nothing to try and limit the voltage or the heat or anything. Everything is just running stock. I'm really impressed with how this is doing so far. Right, let's fast forward 20 minutes. Alright, so here we are, 20 minutes later, and I'm absolutely blown away with the performance of this thing. It hasn't got above 59.4 degrees. That's the GPU temperature. The hotspot has peaked at 70.4, and both of those happened. I reset the averages, so the average is 56.6 and 66.9. but since these two peak temperatures, they're about 5 minutes ago, and it hasn't gone back up to those temperatures yet. So I am confident that we are at like the plateau equilibrium temperature for both of those. And we're nowhere near throttling, and we're colder than it would be with the card air-cooled, to the best of my knowledge and research anyway. So I'm so happy with that. I was slightly concerned it would thermal throttle, as I'm sure were lots of you guys. There's so much heat coming out of here though, it feels like a fan heater. So our cooling system is working really nicely. So well done to the little toaster. Next up, we're going to play a game. We're going to play Halo Infinite, just to give it more of like a real world example of what sort of things this will be used for. So let's close this and open that. Alright, so I'm playing Halo Infinite. I'm just kind of running around. It's really hard to get the 4090 to use all its power. This is only a 2K screen. So and I've booted this up before, and it was only using about 250 watts of the graphics card's power. So now I've got it set to run at 5K rather than 2K, and it's still only using 370 watts max. But that's doing that, and then the CPU is using an additional 120 watts. So I think we've shown it works, but we really want to do a full stress test with everything running at maximum. So I'm going to close this, and I'm going to run Firmark and Cinebench at the same time and do a proper hell test for this thing and see if we can get it to thermal throttle at all, because it seems to be handling everything far too well right now. So I've got everything ready for the full-on hell test here. I am screen recording. I have got Cinebench open. I'm going to do a multi-core Cinebench test. I've got the temperatures shown here for the two M.2 drives. Got the fan software up here so you can see, I mean, we're going to be at maximum fan speeds this whole time. And then over here we've got, obviously as before, CPU core temperatures and package temperatures on show there, the CPU wattage, VRM temperatures, GPU temperatures, and GPU wattage is there. So I'm going to start Firmark, which will be on the other screen, not the one that's being recorded here. So let's get that going, and the Cinebench multi-core test at the same time. And I think this is where it's very likely to thermal throttle. And we are currently drawing, what's that, 670 watts in total across the CPU and the graphics card. I mean, it's not instantly thermal throttling, which is amazing. I think it will though. I think it'll get up to temperature. There's a lot of heat coming out. Ambient temperature in the room is 21.8, so we've gone up by about half a degree over the last hour or two. Somehow the GPU is still at 56, CPU is at 75. On the cores, the package is at 86. None of the case is super hot. It's definitely below human body temperature, but it's just like a fan heater coming out of here. One of the cores has hit 95 once, it's now back down to 88. This is pretty nuts that this can handle this, even for 2 minutes. Okay, so we're 5 minutes in, and the first core has thermal throttled, and now so have a few more. So we've got, I mean, it's saying it is, but none of them have hit 100. I'll be honest, guys, like, testing like this is not my area of expertise, so I'm fairly limited on my knowledge of how hardware info works. It seems to say it is thermal throttling, but that's not because of the specific core temperature. It's because something has caused it to throttle down inside the CPU based on various temperatures. If someone can explain this better, I'd really appreciate that. So, CPU is starting to almost hit 100 now, but we've been running this for 6 solid minutes. There we go. We've hit 100 on cores 4 and 5. GPU though, sitting at a nice cool 65-ish. Hotspot around 77, 78. The drives, we've got one at 64 degrees. The main one is still at 59 degrees, so everything kind of deep inside the motherboard there is fine. VRM also completely fine, 77 degrees, that's not a problem at all. The heat coming out of here is getting to the point where I'm getting a bit sweaty just being near it, and I don't think I could hold my hand there for more than about 10 seconds without it starting to hurt. So that's pretty cool. The case though is not getting unreasonably hot, not remotely kind of dangerous or anything to touch it. This side of the case is still nice and cold because that's all the air intake on the back. So all the heat is coming out of here. So all the P cores now have thermal throttled. But it took a while to get there. I mean, I'm pretty amazed by the performance of this little thing. But we're going to keep testing it. According to Intel, the new BIOS updates make the CPU safe. So doing this shouldn't really be doing any damage to anything, I hope. VRMs have hit 80 now, which is still completely fine. GPU is still about the temperature it would be with an air-cooled card in any normal case. And ambient temperature is 22.1 now. This thing is really heating up the room. So we're about 20 minutes into our simultaneous Firmark and Cinebench test, and it looks like 6 of the 8 P cores have now hit 100, which was to be expected with both of these things running at the same time. The heat being kicked out is just absurd. I've never felt a PC with this amount of heat coming out such a small area. It's completely nuts. The 2 drives, the hotter of the M.2 drives has peaked at 68. The other one has stayed at 59, which is quite impressive. Yeah, the active cooling on the motherboard is really doing its thing here because it's also kept the VRM at 86, which is quite good with everything that's going on in there, and it's right in the middle there. And we've cut the top off it. To keep that at 86 is good. I'm considering that a big win, that's not kind of getting dangerously hot. The CPU has been putting out 253 watts this entire time. The graphics card has been putting out 430 watts. So it's just a massive amount of heat. And even with the CPU running at 100% to 100 degrees and running a non-stop Firmark test for over 20 minutes, the graphics card is nowhere near thermal throttling. We're at 69.7, that's the maximum temperature. And then the hotspot maximum is 82, but that doesn't thermal throttle at the thermal limit of 83. That's my understanding anyway. I believe the GPU temperature would have to get to 83 for it to throttle, so that's awesome. Cinebench is about to finish, as is, well, I can stop Firmark whenever I want. So when Cinebench finishes, I'm going to stop Firmark as well, and we can just see how quickly all the temperatures come back down. Okay, so that's everything stopped. CPU's back down to 50 fairly immediately. GPU back down to the high 40s. Alright, and a few minutes have passed and everything is nice and quiet. Everything's cooled back down to a nice idle temperature now. And that's it. That's the end of the testing. I'm amazed that it performs as well as it does. It doesn't thermal throttle when you do a CPU only load. Doesn't thermal throttle when you do a GPU only load. When you run both at the same time in a completely unrealistic test, only the CPU thermal throttles. It takes 5 minutes to do that, and even then it's not like bouncing off 100 degrees. It's very slowly getting there, never going above 100. And bear in mind, we haven't even considered undervolting anything. Everything is stock. We've got the stock BIOS settings other than the fan curves. Yeah, I want to keep it, but I can't because the customer's been waiting 8 months for this thing. So yeah, I'm going to very happily give them a call and tell them that it's fully working, fully tested, and it can pretty much take anything they're going to throw at it. So good result. And here's just a quick summary of all the temperatures and the wattages throughout the tests. Bear in mind though guys that this is quite an unscientific test. There are a lot of background tasks going on that the PC was running. The CPU idle in particular fluctuated wildly between about 15 watts and about 60 watts. Because as I said, we're screen recording, we've got various monitoring softwares open, we're downloading things at the same time. It's really just proof to us and proof to the customer of its performance. And it's gone really well. The only time it thermal throttled was with, I say it's a completely unrealistic test. There are some games that will run the CPU and the GPU on full, but it's very rare. And in that instance, it takes 5 to 10 minutes for the CPU cores to reach 100 degrees. Before we started any of this, we did say to the customer, look, it might thermal throttle in this case that you've chosen. And they were very much aware of that. So this is not, we're not letting anyone down by it thermal throttling. And the most important part of this is the gaming performance, and the GPU is nowhere near throttling, which is such a big achievement. We're really happy with that. And doing anything else in the real world, the CPU and the GPU are both perfectly within spec temperature wise. The CPU, it's a hot CPU, so that was always going to be tough, but I think we achieved everything we wanted to do here. So sadly that is the end of the series for the toaster, but we're so happy with how this has turned out. I hope you guys have liked following the journey, and yeah, sorry it's taken so long to get finished, but we just became obsessed with perfecting every single part of this, and I really hope that shows. I think the end result is amazing. It's performed better than I thought it would, and yeah, I'm just thrilled with it. I really hope the customer likes it. We've been getting various updates from them throughout the journey, and they love it. But yeah, hopefully when they see it in person, it'll be worth the wait to them. It definitely wouldn't have turned out as well as it did if it wasn't for you guys watching. There's something about building something while filming it and putting it online in front of thousands of people that makes you really agonize over every single aspect of this. So yeah, all of you watching, you've really helped this to become what it has become. And yeah, please do subscribe to the channel. We're getting a lot more views on our videos than we have subscribers, so yeah, it would help us out if you subscribed, if you want to see more. We've got another build on the go already, which we started a while back, but we took a break on that to finish this. And we've got lots more builds coming up in the future. I need a new PC to edit on, so I'm going to be building that. We've got some updates and some more progress on the CPU block we're developing, which some of you might have seen. But yeah, I won't go into all that in too much detail. You're all awesome. The PC's awesome. It works great. Thank you so much for watching. Take care. Bye.